Preface. Welcome to Fundamentals of Machine Learning. This book is designed to provide a comprehensive introduction to the field of machine learning and artificial intelligence. The chapters within cover a wide range of topics, from the basics of artificial intelligence and the differences between classical programming and AI, to advanced techniques in deep learning, reinforcement learning, and large language models. We start by exploring the foundations of artificial intelligence, including the definition and scope of machine learning, and the differences between supervised, unsupervised, and reinforcement learning. We then delve into the various types of machine learning algorithms, including linear regression, logistic regression, decision trees, neural networks, and clustering. In addition to these core concepts, we also examine the practical applications of machine learning in fields such as computer vision, natural language processing, and bioinformatics. We discuss the challenges and limitations of machine learning, as well as the ethical considerations and potential risks associated with its use. Throughout the book, we provide numerous examples and case studies to illustrate the concepts discussed. These include image classification, speech recognition, recommendation systems, and more. By working through these examples, readers will gain a deeper understanding of how machine learning algorithms work and how they can be applied in real-world scenarios. Whether you are a student looking to learn the basics of machine learning or a professional seeking to expand your knowledge and skills, this book is designed to provide a comprehensive and accessible introduction to the field. So, let's get started on our journey through the fundamentals of machine learning. Introduction. Welcome to Fundamentals of Machine Learning. This book is designed to provide a comprehensive introduction to the field of machine learning, without compromising on clarity or accuracy. Unlike other books on the subject, we have made a conscious effort to explain complex concepts in simple language, avoiding the use of advanced mathematics and code examples wherever possible. Our goal is to help readers understand the core fundamentals of machine learning and artificial intelligence, and how they can be applied to real-world problems. We begin by introducing the basics of machine learning, including supervised and unsupervised learning, as well as the various algorithms used in each category. We then delve deeper into topics such as regression analysis, classification, clustering, and neural networks, providing practical examples and illustrations to help readers visualize the concepts. Throughout the book, we have maintained a focus on practical applications of machine learning, highlighting how these techniques can be used in a variety of fields, including healthcare, finance, marketing, and more. We also provide insights into the ethical considerations of machine learning, such as data privacy and bias, to ensure that readers are fully aware of the implications of their work. Whether you are a beginner looking to get started in machine learning or an experienced professional seeking to expand your knowledge, Fundamentals of Machine Learning is the perfect resource for you. With its accessible language and practical approach, this book is ideal for anyone looking to gain a solid understanding of this rapidly evolving field. So let's get started on our journey into the fascinating world of machine learning. Artificial intelligence, the future of problem solving. Artificial intelligence, AI, is a rapidly growing field that has been gaining significant attention in recent years. It refers to the development of computer systems that can perform tasks that typically require human intelligence, such as learning, problem solving, and decision making. AI has the potential to revolutionize numerous industries and transform the way we live and work. In this chapter, we will explore the concept of AI, its significance in the field of technology, and its potential applications in various fields. The concept of artificial intelligence. AI is a broad field that encompasses several subfields, including machine learning, natural language processing, computer vision, and robotics. Machine learning is a subset of AI that focuses on developing algorithms that can learn from data and improve their performance over time. Natural language processing involves the development of systems that can understand and generate human language, while computer vision enables computers to interpret and analyze visual data from images and videos. Robotics combines AI with mechanical engineering to create intelligent robots that can perform tasks such as assembly, maintenance, and navigation. The significance of artificial intelligence in technology. AI has the potential to transform numerous industries, including healthcare, finance, transportation, and education. In healthcare, AI can be used to develop diagnostic tools that can analyze medical images and identify diseases more accurately than human doctors. In finance, AI can help detect fraud and make investment decisions based on complex data analysis. In transportation, AI can enable self-driving cars that are safer and more efficient than traditional vehicles. In education, AI can create personalized learning plans for students based on their individual strengths and weaknesses. Potential applications of artificial intelligence. AI has numerous potential applications in various fields, including 1. Healthcare. AI can be used to develop diagnostic tools that can analyze medical images and identify diseases more accurately than human doctors. It can also help with drug discovery and personalized treatment plans. 2. Finance. AI can help detect fraud and make investment decisions based on complex data analysis. It can also enable automated trading systems that can make quick and accurate decisions in real time. 3. Transportation. AI can enable self-driving cars that are safer and more efficient than traditional vehicles. It can also improve traffic flow and reduce congestion by optimizing traffic light timing and routing. 4. Education. AI can create personalized learning plans for students based on their individual strengths and weaknesses. It can also help teachers identify areas where students need improvement and provide tailored feedback. 5. Manufacturing. AI can optimize manufacturing processes by analyzing data from sensors and machines to identify inefficiencies and improve productivity. 6. Energy. AI can optimize energy consumption and production by analyzing data on energy usage patterns, weather forecasts, and energy prices. 7. Agriculture. AI can optimize crop yields and reduce waste by analyzing data on soil conditions, crop health, and weather patterns. Challenges and limitations of artificial intelligence. While AI has the potential to transform numerous industries, it also poses several challenges and limitations, including 1. Data quality. AI algorithms require high-quality data to produce accurate results. Poor data quality can lead to biased or inaccurate results. 2. Bias. AI algorithms can perpetuate biases and stereotypes present in the training data, leading to unfair outcomes. 3. Security. AI systems can be vulnerable to cyber attacks and data breaches, which can have serious consequences. 4. Explainability. AI algorithms can be difficult to interpret and understand, making it challenging to explain their decisions and actions. 5. Ethics. AI raises ethical concerns around privacy, fairness, and accountability, particularly in areas such as healthcare and finance. Conclusion. Artificial intelligence has the potential to revolutionize numerous industries and transform the way we live and work. While it poses several challenges and limitations, its significance in technology and problem solving cannot be overstated. As AI continues to evolve and improve, it is essential to address these ethical concerns and ensure that AI systems are developed and used responsibly. By doing so, we can harness the full potential of AI to create a better future for all. Classical programming vs. Artificial intelligence. Classical programming and artificial intelligence, AI, are two distinct fields that have evolved over time, each with its own set of principles, methods, and applications. While classical programming focuses on designing and developing software systems that perform specific tasks, AI is centered around the creation of intelligent machines that can learn, reason, and act autonomously. In this chapter, we will delve into the differences between these two fields, highlighting their unique aspects and approaches. 1. Problem-solving approach. Classical programming involves writing code to solve specific problems, whereas AI adopts a more general problem-solving approach. AI algorithms are designed to learn from data and adapt to new situations, whereas classical programming relies on predefined rules and procedures. 2. Algorithmic thinking. Classical programming involves writing algorithms that follow a set of predefined rules, while AI focuses on discovering patterns in data and learning from it. AI algorithms are designed to learn and improve over time through machine learning techniques. 3. Data vs. knowledge. Classical programming relies on explicit knowledge representation, where data is stored in tables or files, whereas AI leverages implicit knowledge representation, where machines can learn from data and make predictions or decisions without being explicitly programmed. 4. Human-computer interaction. Classical programming focuses on designing user interfaces and developing software applications that interact with humans through predefined inputs and outputs, while AI aims to create more natural language processing and dialogue systems that can understand and respond to human emotions and intentions. 5. Learning vs. optimization. Classical programming involves writing code that follows a set of rules or algorithms to solve a problem, whereas AI focuses on optimizing its performance through machine learning techniques, such as supervised and unsupervised learning, deep learning, and reinforcement learning. 6. Performance evaluation. Classical programming is evaluated based on the correctness and efficiency of the code, while AI algorithms are assessed based on their ability to learn from data, adapt to new situations, and improve over time. 7. Computational complexity. Classical programming has a fixed computational complexity. As the size of the problem increases, so does the time required to solve it. AI algorithms have varying computational complexities, depending on the type of problem they are designed to solve. 8. Robustness and security. Classical programming focuses on developing software systems that are robust and secure, whereas AI aims to create machines that can learn from data and adapt to new situations while ensuring privacy and security. 9. Interdisciplinary approach. Classical programming is primarily focused on computer science, while AI draws upon techniques and theories from multiple fields, including mathematics, statistics, neuroscience, philosophy, and cognitive science. 10. Future implications. Classical programming will continue to evolve and improve the efficiency of software systems, whereas AI has the potential to revolutionize various industries, such as healthcare, finance, transportation, and education. by creating intelligent machines that can learn from data and adapt to new situations. In conclusion, classical programming and AI are two distinct fields with their unique approaches, methods, and applications. While classical programming focuses on designing software systems that perform specific tasks, AI aims to create intelligent machines that can learn, reason, and act autonomously. Understanding the differences between these two fields is essential for developing innovative solutions in the field of machine learning. Machine learning, fundamentals and applications. Machine learning is a subfield of artificial intelligence, AI, that involves the use of algorithms to analyze and learn patterns within data, without being explicitly programmed to do so. The goal of machine learning is to enable machines to make predictions or take actions based on data, rather than relying on human intervention. In this chapter, we will explore the fundamentals of machine learning, its applications, and its role in AI. Fundamentals of machine learning. Machine learning algorithms can be broadly classified into two categories: supervised and unsupervised learning. Supervised learning involves training a machine learning model on labeled data, where the target output is known. The goal is to learn a mapping between input features and corresponding outputs, so that the model can make predictions on new, unseen data. Examples of supervised learning tasks include image classification, speech recognition, and sentiment analysis. Unsupervised learning, on the other hand, involves training a machine learning model on unlabeled data. The goal is to discover hidden patterns or structure in the data without any prior knowledge of the output. Examples of unsupervised learning tasks include clustering, dimensionality reduction, and anomaly detection. In addition to these two main categories, there are also other types of machine learning algorithms such as reinforcement learning, which involves training a model to make decisions based on rewards or penalties, and deep learning, which involves the use of neural networks to learn complex patterns in data. Applications of machine learning. Machine learning has numerous applications across various industries, including 1. Healthcare. Machine learning can be used to analyze medical images, diagnose diseases, and develop personalized treatment plans. 2. Finance. Machine learning can be used to detect fraud, predict stock prices, and optimize investment portfolios. 3. Retail. Machine learning can be used to recommend products, predict customer behavior, and optimize supply chain management. 4. Manufacturing. Machine learning can be used to optimize production processes, predict equipment failure, and improve product quality. 5. Transportation. Machine learning can be used to develop autonomous vehicles, optimize traffic flow, and improve route planning. Role of machine learning in AI. Machine learning is a critical component of artificial intelligence, AI. It provides the ability for machines to learn from data and make predictions or decisions without human intervention, which is at the core of what AI is all about. Without machine learning, many of the AI applications we see today would not be possible. Machine learning is also enabling the development of more advanced AI technologies such as natural language processing, NLP, computer vision, and robotics. These technologies are becoming increasingly important in various industries and have the potential to revolutionize many aspects of our lives. In conclusion, machine learning is a fundamental aspect of artificial intelligence that enables machines to learn from data and make predictions or decisions without human intervention. Its applications are vast and varied, and it plays a critical role in many industries. As AI continues to evolve and advance, the importance of machine learning will only continue to grow. Deep learning in machine learning. Deep learning is a subfield of machine learning that focuses on developing artificial neural networks with multiple layers to analyze and learn complex patterns in data. These neural networks are capable of automatically extracting features from raw data, such as images, text, or audio, and can be trained to perform tasks such as image recognition, natural language processing, and speech recognition. The significance of deep learning. Deep learning has revolutionized the field of machine learning and artificial intelligence in recent years. Its ability to automatically extract features from raw data has made it an essential tool for various applications, including 1. Image recognition. Deep learning algorithms can be trained to recognize objects in images, classify them into different categories, and even perform actions such as facial recognition. 2. Natural language processing. Deep learning models can be used to process and analyze natural language data, enabling applications such as text classification, sentiment analysis, and machine translation. 3. Speech recognition. Deep learning algorithms can be trained to recognize spoken words and phrases, allowing for applications such as voice assistants and speech-to-text systems. 4. Predictive modeling. Deep learning models can be used to predict outcomes based on large datasets, enabling applications such as fraud detection, medical diagnosis, and financial forecasting. The key concepts of deep learning. 1. Artificial neural networks. ANNs. ANNs are the foundation of deep learning. They consist of multiple layers of interconnected nodes that process inputs and produce outputs. 2. Activation functions. These functions determine the output of each node in an ANN, based on the weighted sum of inputs passed through it. Common activation functions include sigmoid, tanh, and ReLU. 3. Backpropagation. This is an algorithm used to train ANNs by minimizing the error between predicted outputs and actual outputs. It involves adjusting the weights of connections between nodes to improve the model's performance. 4. Convolutional neural networks. CNNs. These are specialized types of ANNs designed for image recognition tasks. They use convolutional and pooling layers to extract features from images. 5. Recurrent neural networks. RNNs. These are types of ANNs that can process sequential data, such as speech or text. They use loops to feed information from one time step to the next. The future of deep learning. Deep learning is a rapidly evolving field, with new techniques and applications being developed continuously. Some of the future trends in deep learning include 1. Adversarial training. This involves training ANNs to be more robust against attacks by generating adversarial examples, which are inputs specifically designed to cause errors in the model's predictions. 2. Explainability and interpretability. There is a growing interest in developing techniques that can explain and interpret the decisions made by deep learning models, ensuring transparency and accountability in their use. 3. Edge AI. With the proliferation of IoT devices, there is a growing need for AI models that can run on edge devices with limited computing resources, enabling real-time processing and decision-making. 4. Multimodal learning. Deep learning models are increasingly being used to process and analyze data from multiple sources, such as images, text, and audio, to improve the accuracy of predictions and decision-making. Applied vs. Generalized AI. In the field of artificial intelligence, AI, there are two main categories of AI systems: applied and generalized. While both types of systems aim to simulate human intelligence, they differ in their approach and application. In this chapter, We will delve into the distinctions between these two categories and explore their respective strengths and limitations. Applied Artificial Intelligence (AI). Applied AI refers to the use of AI techniques to solve specific problems or perform particular tasks. This type of AI is typically designed to handle a well-defined problem domain, such as image recognition, natural language processing, or decision-making. Applied AI systems are trained on large datasets and are optimized for a specific task, making them highly accurate and efficient within their designated scope. Examples of applied AI include 1. Image recognition software that can identify objects in images with high accuracy. 2. Virtual assistants like Siri or Alexa, which can understand and respond to voice commands. 3. Fraud detection systems that can analyze financial transactions to identify potential fraud. 4. Self-driving cars that can navigate roads and make decisions based on sensor data. Strengths of applied AI include 1. High accuracy and efficiency in solving specific tasks. 2. Ability to handle complex, real-world problems. 3. Can be trained on large datasets for improved performance. 4. Potential to revolutionize various industries such as healthcare, finance, and transportation. Weaknesses of applied AI include 1. Limited flexibility in adapting to new tasks or situations. 2. Dependence on high-quality training data. 3. Vulnerability to overfitting or underfitting the training dataset. 4. Potential for ethical concerns, such as privacy invasion or bias in decision-making. Generalized Artificial Intelligence (AI). Generalized AI, on the other hand, aims to create machines that can learn and adapt across multiple domains and tasks. This type of AI seeks to replicate human intelligence by enabling machines to reason, plan, and make decisions in a wide range of situations. Generalized AI systems are designed to learn from experience and adapt to new environments, much like humans do. Examples of generalized AI include 1. Chatbots that can handle customer inquiries across multiple channels and topics. 2. Autonomous vehicles that can navigate different road types and traffic patterns. 3. Personal assistants that can schedule appointments, set reminders, and provide recommendations based on user preferences. 4. Robots that can perform various tasks such as assembly, maintenance, or inspection. Strengths of generalized AI include 1. Ability to adapt to new situations and tasks. 2. Potential to solve complex problems that require human-like reasoning. 3. Capability to operate in diverse environments and contexts. 4. Can handle tasks that are not easily defined or structured. Weaknesses of generalized AI include 1. Requires a vast amount of training data and computational resources. 2. May struggle with tasks that require explicit rules or instructions. 3. Vulnerable to overfitting due to the complexity of the learning process. 4. Ethical concerns, such as potential for bias in decision-making or privacy invasion. Comparison of applied and generalized AI. When comparing applied and generalized AI, it's essential to understand their respective strengths and limitations. Applied AI is designed for specific tasks and can provide high accuracy within those domains, while generalized AI seeks to replicate human intelligence across multiple tasks and environments. Advantages of applied AI include 1. High accuracy in solving specific problems. 2. Ability to handle complex real-world problems. 3. Can be trained on large datasets for improved performance. 4. Potential to revolutionize various industries. Disadvantages of applied AI include 1. Limited flexibility in adapting to new tasks or situations. 2. Dependence on high-quality training data. 3. Vulnerability to overfitting or underfitting the training dataset. 4. Potential for ethical concerns, such as privacy invasion or bias in decision-making. Advantages of generalized AI include: 1. Ability to adapt to new situations and tasks. 2. Potential to solve complex problems that require human-like reasoning. 3. Capability to operate in diverse environments and contexts. 4. Can handle tasks that are not easily defined or structured. Disadvantages of generalized AI include: 1. Requires a vast amount of training data and computational resources. 2. May struggle with tasks that require explicit rules or instructions. 3. Vulnerable to overfitting due to the complexity of the learning process. 4. Ethical concerns, such as potential for bias in decision-making or privacy invasion. Conclusion. In conclusion, applied and generalized AI are two distinct categories of artificial intelligence systems. While applied AI is designed to solve specific problems with high accuracy, generalized AI seeks to replicate human intelligence across multiple tasks and environments. Understanding the strengths and limitations of each type of AI can help developers create more effective and ethical machines that benefit society as a whole. Machine learning features and labels. In machine learning, features and labels are two crucial components that play a vital role in training and testing models. Features refer to the input variables or attributes of a dataset, while labels represent the target or output variable that the model is trying to predict or classify. Understanding the concepts of features and labels is essential for any machine learning practitioner, as it can significantly impact the performance of a model. Features are the characteristics of the data that are used to train a machine learning model. They are the inputs that the model uses to make predictions or classifications. Features can be categorical, e.g., gender, numerical, e.g., age, or textual, e.g., product descriptions. The quality and quantity of features can significantly impact the performance of a machine learning model. For example, if a model is trained on a small number of irrelevant features, it may not perform well on new data. On the other hand, if a model is trained on a large number of high-quality features, it may be able to capture complex patterns in the data and make more accurate predictions. Labels are the target or output variable that the machine learning model is trying to predict or classify. Labels can be categorical, e.g., spam, not spam emails, or numerical, e.g., credit risk scores. The quality and quantity of labels can also impact the performance of a machine learning model. For example, if a model is trained on a small number of labeled examples, it may not generalize well to new data. On the other hand, if a model is trained on a large number of high-quality labeled examples, it may be able to capture complex patterns in the data and make more accurate predictions. In supervised learning, the goal is to train a machine learning model to predict or classify labels based on features. The model learns the relationship between the features and the labels by minimizing the error between its predictions and the true labels. Common types of supervised learning tasks include image classification, speech recognition, and sentiment analysis. In unsupervised learning, the goal is to discover patterns or structure in the data without any prior knowledge of the labels. Clustering algorithms are a common type of unsupervised learning algorithm that groups similar examples together based on their features. Other types of unsupervised learning include dimensionality reduction and anomaly detection. In conclusion, Features and labels are two crucial components of machine learning. Understanding these concepts is essential for any machine learning practitioner, as it can significantly impact the performance of a model. By selecting high-quality features and using appropriate labeling techniques, machine learning models can make accurate predictions and classifications. Machine learning training models. Training machine learning models is an essential part of the machine learning pipeline, as it involves preparing and optimizing the model to make predictions on new, unseen data. The goal of training a machine learning model is to find the best possible model parameters that minimize the error between the predicted output and the actual output. In this section, we will cover the process of training machine learning models, including the different types of training algorithms and their respective strengths and weaknesses. Types of training algorithms. There are several types of training algorithms used in machine learning, each with its own set of advantages and disadvantages. Some of the most common training algorithms include 1. Supervised learning. In supervised learning, the model is trained on labeled data, where the target output is known. The goal is to learn a mapping between input features and the corresponding target output. Common algorithms used in supervised learning include linear regression, logistic regression, decision trees, and support vector machines, SVMs. 2. Unsupervised learning. In unsupervised learning, the model is trained on unlabeled data, and the goal is to identify patterns or structure in the data. Common algorithms used in unsupervised learning include k-means clustering, principal component analysis, PCA, and T-SNE, T-distributed stochastic neighbor embedding. 3. Reinforcement learning. In reinforcement learning, the model learns by interacting with an environment and receiving feedback in the form of rewards or penalties. The goal is to learn a policy that maximizes the cumulative reward over time. Common algorithms used in reinforcement learning include Q-learning, SARSA, state action reward state action, and deep reinforcement learning. 4. Semi-supervised learning. In semi-supervised learning, the model is trained on a combination of labeled and unlabeled data. The goal is to leverage the labeled data to guide the training process while also leveraging a large amount of unlabeled data to improve the generalization of the model. Common algorithms used in semi-supervised learning include self-training, co-training, and transfer learning. Training process. The training process for machine learning models typically involves the following steps. 1. Data preparation. The first step is to collect and pre-process the data, including cleaning, normalizing, and transforming the data into a format suitable for training. 2. Model selection. Next, the appropriate machine learning algorithm must be selected based on the type of problem being solved and the characteristics of the data. 3. Hyperparameter tuning. Once the algorithm has been selected, the hyperparameters of the model must be tuned to optimize the performance of the model. This involves adjusting parameters such as learning rates, regularization strength, and number of hidden layers in a neural network. 4. Training. The model is then trained on the labeled training data using an optimization algorithm such as gradient descent or stochastic gradient descent. 5. Evaluation. After training, the performance of the model must be evaluated on a separate test set to estimate a generalization error of the model. 6. Hyperparameter tuning. Optional. If the performance of the model is not satisfactory, the hyperparameters may need to be further optimized using techniques such as grid search or Bayesian optimization. 7. Model deployment. Finally, the trained model can be deployed in a production environment to make predictions on new data. Conclusion. Training machine learning models involves preparing and optimizing the model using a variety of algorithms and techniques. Understanding the different types of training algorithms and their respective strengths and weaknesses is essential for selecting the appropriate algorithm for a given problem. By following the steps outlined above, you can train a machine learning model that is optimized to make accurate predictions on new data. Training models in machine learning. In machine learning, there are several types of training models that are commonly used for different applications. These models can be broadly classified into two categories: supervised learning models and unsupervised learning models. Supervised learning models require labeled data to train the model, while unsupervised learning models do not require labeled data. Supervised learning models. Supervised learning models are trained using labeled data, where the target variable is known. These models are used for classification and regression tasks. Some of the commonly used supervised learning models include: 1. Linear regression. This model is used for linear regression tasks, where the goal is to predict a continuous value based on one or more input features. 2. Logistic regression. This model is used for binary classification tasks, where the goal is to predict a binary label, e.g., 0 or 1, based on one or more input features. 3. Decision trees. This model is used for both classification and regression tasks. It works by recursively partitioning the data into smaller subsets based on the values of the input features. 4. Random forests. This model is an ensemble learning method that combines multiple decision trees to improve accuracy and reduce the overfitting of the model. 5. Support vector machines, SVMs. This model is used for both classification and regression tasks. It works by finding the hyperplane that maximally separates the classes in the feature space. Unsupervised learning models. Unsupervised learning models are trained using unlabeled data, where there is no target variable. These models are used for exploratory data analysis, anomaly detection, and clustering tasks. Some of the commonly used unsupervised learning models include: 1. K-means clustering. This model is used for clustering data into K-groups based on their similarity. 2. Hierarchical clustering. This model is used for building a hierarchy of clusters by merging or splitting existing clusters. 3. Principal component analysis, PCA. This model is used for reducing the dimensionality of the data by projecting it onto a lower dimensional space. 4. T-distributed stochastic neighbor embedding, TSNE. This model is used for visualizing high-dimensional data in a lower dimensional space while preserving the local structure of the data. 5. Autoencoders. This model is used for dimensionality reduction, anomaly detection, and generative modeling tasks. Training process. The training process for machine learning models involves several steps. 1. Data preparation. The first step is to collect and pre-process the data, including cleaning, normalizing, and transforming it into a format suitable for training. 2. Model selection. Next, the appropriate model must be selected based on the type of problem and the characteristics of data. 3. Hyperparameter tuning. After selecting the model, the hyperparameters must be tuned to optimize its performance. This involves adjusting the model's parameters to improve its accuracy and reduce its overfitting. 4. Training. Once the hyperparameters are optimized, the model is trained on the labeled data using an optimization algorithm such as gradient descent or stochastic gradient descent. 5. Evaluation. After training, the model must be evaluated on a holdout set to assess its performance and make any necessary Adjustments. 6. Deployment. Finally, the trained model can be deployed in a production environment to perform the desired task. In conclusion, there are various types of training models used in machine learning, each with its strengths and weaknesses. The choice of model depends on the problem domain and the characteristics of the data. The training process involves several steps, including data preparation, model selection, hyperparameter tuning, training, evaluation, and deployment. Hyperparameter tuning in machine learning. Hyperparameter tuning is a crucial step in the machine learning milliliter pipeline that involves optimizing the performance of milliliter models by adjusting their hyperparameters. Hyperparameters are parameters that are set before training in milliliter model, such as learning rate, regularization strength, and number of hidden layers in a neural network. The goal of hyperparameter tuning is to find the best combination of hyperparameters that result in the highest accuracy or F1 score for a given dataset. Importance of hyperparameter tuning. 1. Improved model performance. By optimizing hyperparameters, you can significantly improve the performance of your milliliter model. A good hyperparameter tuning process can lead to better accuracy, lower error rates, and higher F1 scores. 2. Reduced training time. Hyperparameter tuning can help reduce the training time of your milliliter model. By finding the optimal combination of hyperparameters, you can speed up the training process without compromising on model performance. 3. Increased model robustness. Tuning hyperparameters helps make your milliliter model more robust and less sensitive to variations in a dataset or environmental factors. A well-tuned model is more likely to generalize better to new data and produce consistent results. 4. Better resource allocation. Hyperparameter tuning involves adjusting the learning rate, regularization strength, and other hyperparameters that affect how much resources, e.g., computational power, memory, and milliliter model consumes during training. By optimizing these hyperparameters, you can allocate resources more efficiently and avoid overfitting or underfitting your dataset. 5. Improved model interpretability. Hyperparameter tuning can also help improve the interpretability of your milliliter model. By identifying the most critical hyperparameters that affect model performance, you can gain insights into how your model works and what features are most important for its predictions. Techniques for optimization. 1. Grid search. One popular technique for hyperparameter tuning is grid search, which involves searching through a predefined set of hyperparameters to find the optimal combination. While grid search can be computationally expensive, it provides a comprehensive view of how different hyperparameters affect model performance. 2. Random search. Random search is another technique that involves randomly sampling the space of hyperparameters to find the optimal combination. This approach can be faster than grid search but may not explore the entire space of hyperparameters thoroughly. 3. Bayesian optimization. Bayesian optimization is a more advanced technique that uses a probabilistic model to guide a search for optimal hyperparameters. This approach can be computationally efficient and provide a better balance between exploration and exploitation. 4. Gradient-based optimization. Gradient-based optimization techniques, such as gradient descent, can also be used for hyperparameter tuning. These methods are commonly used in deep learning but may not be as effective for other milliliter models. 5. Model selection. Finally, model selection is a technique that involves choosing the best milliliter model for a given dataset without hyperparameter tuning. While this approach may not provide optimal performance, It can simplify the milliliter development process and reduce the need for extensive hyperparameter tuning. Conclusion. Hyperparameter tuning is a critical step in the milliliter pipeline that can significantly impact model performance, training time, robustness, and interpretability. By employing various techniques for optimization, you can find the best combination of hyperparameters to achieve optimal results for your milliliter models. Remember, the choice of technique depends on the complexity of the problem, available computational resources, and personal preferences. Machine learning, supervised learning. Supervised learning is a type of machine learning where the algorithm is trained using labeled data. In other words, the algorithm learns from data that has been pre-classified into different categories or classes. The goal of supervised learning is to make predictions on new, unseen data based on the patterns and relationships learned from the labeled training data. In supervised learning, the algorithm is presented with input features, also called predictor variables, and corresponding output labels. Target variable. The algorithm learns to map the input features to the appropriate output label based on the training data. The process of supervised learning can be summarized as follows. 1. Data preparation. The first step is to collect and pre-process the data. This includes cleaning, normalizing, and transforming the data into a format that can be used by the machine learning algorithm. 2. Model selection. Next, the appropriate machine learning algorithm must be selected based on the type of problem being solved and the characteristics of the data. Common algorithms used in supervised learning include linear regression, logistic regression, decision trees, random forests, and support vector machines, SVMs. 3. Training. Once the algorithm has been selected, the model is trained using the labeled training data. The goal is to minimize the difference between the predicted outputs and the actual labels. 4. Evaluation. After training, the performance of the model must be evaluated using various metrics such as accuracy, precision, recall, F1 score, etc. This helps in determining the strengths and weaknesses of the model. 5. Hyperparameter tuning. Many machine learning algorithms have hyperparameters that need to be optimized for optimal performance. This involves adjusting the parameters of the algorithm to improve its accuracy on unseen data. 6. Model deployment. Once the model has been trained and evaluated, it can be deployed in a production environment where it can be used to make predictions on new, unseen data. Advantages of supervised learning. 1. Improved accuracy. Supervised learning can lead to improved accuracy compared to other machine learning techniques, such as unsupervised learning or reinforcement learning. 2. Efficient use of data. By using labeled data, supervised learning allows for an efficient use of the available data. 3. Faster training times. Supervised learning algorithms typically have faster training times compared to other machine learning techniques. 4. Improved interpretability. The use of labeled data in supervised learning provides more interpretability compared to other machine learning techniques. 5. Robustness to noise. Supervised learning can be more robust to noisy data compared to unsupervised learning. Reinforcement learning. Challenges of supervised learning. 1. Limited data quality. The quality of the labeled training data can significantly impact the performance of supervised learning algorithms. Poor quality data can lead to biased models that perform poorly on new, unseen data. 2. Overfitting. Supervised learning algorithms can suffer from overfitting, especially when dealing with complex datasets or high-dimensional feature spaces. Overfitting occurs when the model learns the noise in the training data rather than the underlying patterns. 3. Class imbalance. Class imbalance can occur when the number of instances in one class significantly outnumbers the number of instances in the other class. This can lead to biased models that perform poorly on minority classes. 4. Label leakage. Label leakage occurs when the model learns the labels rather than the underlying patterns in the data. This can result in poor generalization performance on new, unseen data. 5. Computational cost. Supervised learning algorithms can be computationally expensive, especially when dealing with large datasets or complex models. Real-world applications of supervised learning. 1. Image classification. Supervised learning is widely used in image classification tasks such as object detection, facial recognition, and medical imaging analysis. 2. Natural language processing. NLP. NLP applications such as sentiment analysis, text classification, and machine translation rely heavily on supervised learning algorithms. 3. Fraud detection. Supervised learning can be used to detect fraudulent transactions in various domains such as finance, insurance, and e-commerce. 4. Predictive maintenance. Supervised learning can be applied to predict equipment failure or maintenance needs based on historical data from sensors and logs. 5. Recommendation systems. Many recommendation systems rely on supervised learning algorithms to learn user preferences and make personalized recommendations. In conclusion, supervised learning is a powerful tool in machine learning that can be used to solve various problems by leveraging labeled training data. However, it also has its challenges such as limited data quality, overfitting, class imbalance, label leakage, and computational cost. By understanding these challenges and utilizing appropriate algorithms, supervised learning can lead to accurate predictions and improved decision-making in various real-world applications. Regression techniques in supervised learning. In supervised learning, the goal is to train a machine learning model on labeled data, where the target variable is continuous or numerical. Regression techniques are used when the goal is to predict a continuous value based on one or more input variables. In this section, we will explore different regression techniques used in supervised learning. 1. Simple linear regression. Simple linear regression is the most basic and widely used regression technique. It involves modeling the relationship between a target variable y and a single input variable x, using a straight line equation. The equation takes the form of y equals beta O plus beta 1 x plus epsilon, where beta 0, beta 1 are the regression coefficients, x is the input variable, and epsilon is the error term. The goal is to estimate the best fitting line that minimizes the sum of the squared errors. Example: predicting house prices based on number of rooms, location, etc. Pros: easy to implement, computationally efficient. Cons: assumes a linear relationship between input and output variables, which may not always hold true. 2. Multiple linear regression. Multiple linear regression is an extension of simple linear regression where there are multiple input variables. The equation takes the form of y equals beta O plus beta 1 by 1 plus beta 2 by 2 plus beta nm xn plus epsilon, where x1, x2, xn are the input variables. Beta 0, beta 1, beta 2, beta nanometer are the regression coefficients, and epsilon is the error term. The goal is to estimate the best fitting linear equation that minimizes the sum of the squared errors. Example: predicting stock prices based on economic indicators such as GDP, inflation rate, etc. Pros: can handle multiple input variables, allows for more accurate predictions. Cons: can be computationally expensive and may not scale well with large datasets. 3. Polynomial regression. Polynomial regression is a type of nonlinear regression where the equation takes the form of y equals beta O plus beta 1 x plus beta 2 x squared plus beta n x caret n plus epsilon, where x is the input variable, beta 0, beta 1, beta 2, beta n are the regression coefficients, and epsilon is the error term. The goal is to estimate the best fitting polynomial equation that minimizes the sum of the squared errors. Example: predicting temperature based on day of the week, time of year, etc. Pros: can handle nonlinear relationships between input and output variables. Cons: may not be computationally efficient for large datasets, and may overfit the data. 4. Ridge regression. Ridge regression is a type of linear regression where the equation takes the form of y equals beta O plus beta 1 x plus epsilon, where x is the input variable, beta 0, beta 1 are the regression coefficients, and epsilon is the error term. The goal is to estimate the best fitting line that minimizes the sum of the squared errors. However, in ridge regression, the regression coefficients are penalized for being too large, which helps to prevent overfitting. Example: predicting customer churn based on usage patterns, etc. Pros: helps to prevent overfitting by penalizing large regression coefficients. Cons: may not be computationally efficient for large datasets. 5. Lasso regression. Lasso regression is a type of linear regression where the equation takes the form of y equals beta O plus beta 1 x plus epsilon, where x is the input variable, beta 0, beta 1 are the regression coefficients, and epsilon is the error term. The goal is to estimate the best fitting line that minimizes the sum of the squared errors. However, in lasso regression, the regression coefficients are penalized for being too large, which helps to prevent overfitting. Additionally, the penalty term is proportional to the absolute value of the regression coefficient, which helps to select the most important features. Example: predicting disease diagnosis based on symptoms, etc. Pros: helps to prevent overfitting by penalizing large regression coefficients and selecting the most important features. Cons: may not be computationally efficient for large datasets. Classification techniques in supervised learning. In supervised learning, the goal is to train a machine learning model to predict a categorical output or label based on input features. The task of classification involves grouping similar examples together and distinguishing them from dissimilar examples. There are several techniques used in supervised learning for classification, including 1. Binary classification. In this technique, the goal is to classify an example as belonging to one of two categories or classes. The most common binary classification algorithms include logistic regression, decision trees, random forests, and support vector machines, SVMs. 2. Multiclass classification. This technique involves classifying examples into more than two categories or classes. Common multiclass classification algorithms include 1 vs rest, OVR, 1 vs all, over, and neural networks. 3. Hierarchical classification. In this technique, the goal is to classify examples into a hierarchy of classes, where each class is a subset of the previous class. Hierarchical classification algorithms include k-means clustering and self-organizing maps. SOMs. 4. Functional classification. This technique involves assigning examples to classes based on their functional properties or characteristics. Common functional classification algorithms include principal component analysis (PCA) and independent component analysis (ICA). 5. Unsupervised learning. In this technique, the goal is to discover hidden patterns or structure in the data without any prior knowledge of class labels. Clustering algorithms such as k-means, hierarchical clustering, and density-based clustering are commonly used for unsupervised learning. 6. Transfer learning. This technique involves using a pre-trained model on one task to perform another related task. The idea is to leverage the knowledge learned from the first task to improve performance on the second task. 7. Active learning. In this technique, the goal is to select the most informative examples from a large dataset and label them manually. The model is then trained on the labeled subset of the data and applied to the remaining unlabeled. Examples. 8. Semi-supervised learning. This technique combines elements of supervised and unsupervised learning by using both labeled and unlabeled data for training. The goal is to improve the accuracy of the model while reducing the amount of labeled data required. 9. Ensemble methods. In this technique, multiple models are trained and their predictions are combined to produce the final output. Ensemble methods can improve the accuracy and robustness of the classification model. 10. Anomaly detection. This technique involves identifying examples that are significantly different from the majority of the data. Anomaly detection algorithms include one-class SVMs, density-based methods, and clustering-based methods. Each of these techniques has its strengths and weaknesses, and the choice of technique depends on the nature of the problem, the size and complexity of the dataset, and the resources available. By understanding the different classification techniques available, machine learning practitioners can select the most appropriate method for their specific application. Practical applications of supervised machine learning. Supervised machine learning is a powerful tool that has numerous practical applications in various fields. Here are some examples of how supervised machine learning can be applied in real-world scenarios. 1. Image recognition. Supervised machine learning can be used to train a model to recognize objects in images. For example, a model can be trained to detect faces, cars, or other objects in photos or videos. This application can have numerous use cases such as facial recognition for security purposes, self-driving cars that can detect objects on the road, or personalized image search engines that can recognize objects in images. 2. Natural language processing, NLP. Supervised machine learning can be used to build chatbots, sentiment analysis tools, and language translation systems. For example, a model can be trained to understand customer queries and provide appropriate responses through a chatbot. Similarly, a model can be trained to analyze customer feedback and predict the sentiment of customers. 3. Fraud detection. Supervised machine learning can be used to detect fraudulent transactions in various industries, such as finance, healthcare, and e-commerce. For example, a model can be trained to identify credit card transactions that are likely to be fraudulent based on historical data and patterns. 4. Predictive maintenance. Supervised machine learning can be used to predict when equipment or machinery is likely to fail. For example, a model can be trained to analyze sensor data from industrial equipment and predict when maintenance is required. This application can help reduce downtime and improve overall efficiency. 5. Healthcare. Supervised machine learning can be used in healthcare to diagnose diseases based on medical images, predict patient outcomes, and identify potential drug targets. For example, a model can be trained to analyze medical images to detect tumors or other abnormalities, or predict the likelihood of a patient developing a particular disease based on their medical history and demographic data. 6. Recommendation systems. Supervised machine learning can be used to build recommendation systems that suggest products or services based on user behavior and preferences. For example, a model can be trained to recommend movies or music based on a user's viewing or listening history. 7. Autonomous vehicles. Supervised machine learning can be used to train autonomous vehicles to recognize objects on the road, such as pedestrians, other cars, and traffic signs. This application can improve safety and reduce accidents caused by human error. 8. Quality control. Supervised machine learning can be used to automate quality control processes in manufacturing and inspection. For example, a model can be trained to detect defects in products based on visual inspections or sensor data. 9. Financial forecasting. Supervised machine learning can be used to predict stock prices, currency exchange rates, and other financial metrics. For example, a model can be trained to analyze historical data and identify patterns that can help predict future market trends. 10. Cybersecurity. Supervised machine learning can be used to detect and prevent cyber attacks by analyzing network traffic and identifying anomalies. For example, a model can be trained to recognize signs of malware infection based on system logs or network activity. These are just a few examples of the many practical applications of supervised machine learning. As the field continues to evolve, we can expect to see even more innovative use cases emerge. Machine learning classification. Classification is a fundamental aspect of machine learning, where the goal is to predict a categorical label or class based on input features. In this chapter, we will explore the principles and applications of classification in machine learning. Principles of classification. Classification involves assigning a predefined label or category to a new observation based on its features. The goal is to maximize the accuracy of predictions while minimizing the number of misclassifications. Here are some key principles of classification. 1. Supervised learning. Classification is a type of supervised learning, where the algorithm learns from labeled examples. The model is trained on a dataset that contains input features and corresponding labels or categories. 2. Types of classes. Classification can involve any number of classes or categories, including binary classification, 2 classes, multi-class classification, more than 2 classes, and hierarchical classification, a tree-like structure with multiple levels. 3. Cost function. The cost function measures the difference between the predicted label and the true label. In classification problems, the cost function is typically the cross-entropy loss function, which measures the logarithmic difference between the predicted probability distribution and the true probability distribution. 4. Optimization algorithms. Classification problems can be solved using various optimization algorithms, such as linear regression, logistic regression, decision trees, random forests, support vector machines, SVMs, and neural networks. Each algorithm has its strengths and weaknesses, and the choice of algorithm depends on the complexity of the problem and the available data. Applications of classification. Classification is widely used in various applications, including 1. Image classification. Classifying images into different categories, such as objects, scenes, or actions. Applications include object detection, facial recognition, and image search. 2. Natural language processing. Classifying text data into categories like sentiment, topic, or genre. Applications include text classification, sentiment analysis, and information retrieval. 3. Healthcare. Classifying patients based on medical diagnoses, treatments, or outcomes. Applications include disease diagnosis, drug discovery, and personalized medicine. 4. Recommendation systems. Classifying users or items into categories like preferences, genres, or popularity. Applications include movie or music recommendations, product recommendations, and personalized advertising. 5. Finance. Classifying financial data into categories like stock prices, credit scores, or insurance risks. Applications include portfolio optimization, fraud detection, and risk management. In conclusion, classification is a fundamental aspect of machine learning that involves predicting a categorical label based on input features. The principles of classification involve supervised learning, types of classes, cost functions, and optimization algorithms. Classification has numerous applications in various fields, including image classification, natural language processing, healthcare, recommendation systems, and finance. By understanding the principles and applications of classification, machine learning practitioners can develop accurate and effective models for a wide range of problems. Machine learning regression. In this chapter, we will delve into the world of regression in machine learning. Regression is a type of supervised learning algorithm that is used to predict a continuous outcome variable based on one or more input features. In this section, we will explore the concept of regression in machine learning and its various applications. What is machine learning regression? Regression is a machine learning algorithm that is used to predict a continuous value, such as a price or a probability, based on one or more input features. The goal of regression is to build a model that can accurately predict the target variable based on the input features. Unlike classification algorithms, which predict a categorical outcome, regression algorithms predict a numerical outcome. Types of machine learning regression. There are several types of machine learning regression algorithms, including 1. Simple linear regression. This is the most basic type of regression algorithm, which models the relationship between the input features and the target variable using a straight line. 2. Multiple linear regression. This algorithm extends simple linear regression by adding multiple input features to the model. 3. Polynomial regression. This algorithm models the relationship between the input features and the target variable using a polynomial equation. 4. Ridge regression. This algorithm is similar to multiple linear regression, but it adds a penalty term for large values of the coefficients to prevent overfitting. 5. Lasso regression. This algorithm is similar to ridge regression, but it uses a different penalty term that leads to more sparse models. 6. Elastic net regression. This algorithm is a combination of ridge and lasso regression, which allows for both feature selection and regularization. Applications of machine learning regression. Machine learning regression has numerous applications in various fields, including 1. Finance. Regression algorithms can be used to predict stock prices, portfolio returns, and credit risk based on economic indicators and financial data. 2. Marketing. Regression algorithms can be used to predict customer churn, response rates, and sales based on customer demographics and behavior. 3. Healthcare. Regression algorithms can be used to predict patient outcomes, such as mortality rates and disease prevalence, based on patient characteristics and medical history. 4. Transportation. Regression algorithms can be used to predict traffic flow, travel times, and route optimization based on transportation infrastructure and traffic data. 5. Energy. Regression algorithms can be used to predict energy consumption and production based on weather patterns, time of day, and energy usage patterns. Challenges in machine learning regression. While machine learning regression has numerous applications, it also faces several challenges, including 1. Data quality. The quality of the input data can significantly affect the accuracy of the regression model. Poor quality data can lead to biased or inaccurate predictions. 2. Feature selection. Selecting the right features for the regression model is crucial for accurate predictions. Features that are not relevant to the problem at hand can lead to poor performance. 3. Overfitting. Regression models can suffer from overfitting, where the model becomes too complex and starts to fit the noise in the data rather than pay underlying patterns. 4. Interpretability. Regression models can be difficult to interpret, making it challenging to understand the relationships between the input features and the target variable. 5. Handling missing values. Regression algorithms can struggle with missing values in the data, which can affect the accuracy of the predictions. In conclusion, machine learning regression is a powerful tool for predicting continuous outcomes based on input features. While it faces several challenges, it has numerous applications in various fields. By understanding the types of regression algorithms and their applications, we can use them effectively to solve real-world problems. In the next chapter, we will explore the concept of clustering in machine learning. Machine learning unsupervised learning. Unsupervised learning is a subfield of machine learning that focuses on training models to find patterns or relationships in data without any prior knowledge of the expected output. In contrast to supervised learning, where the model is trained to predict a specific output based on input features, unsupervised learning algorithms aim to discover hidden structures within the data. The goal of unsupervised learning is to identify groups or clusters in the data that are not obvious from simple inspection of the data. For example, an unsupervised learning algorithm might be used to group customers based on their buying behavior into different segments, such as value seekers, quality conscious, and novelty seekers. By identifying these segments, businesses can tailor their marketing strategies to each group, leading to more effective customer targeting. There are several types of unsupervised learning algorithms, including 1. K-means clustering. This algorithm partitions the data into a specified number of clusters based on the similarity of the data points within each cluster. 2. Hierarchical clustering. This algorithm builds a hierarchy of clusters by merging or splitting existing clusters. 3. Principal component analysis. PCA. This algorithm reduces the dimensionality of the data by projecting it onto a lower dimensional space while retaining as much of the original variation as possible. 4. T-SNE. T-distributed stochastic neighbor embedding. This algorithm maps high-dimensional data to a lower dimensional space in a way that tries to preserve the local structure of the data. 5. Autoencoders. These are neural networks that learn to compress and reconstruct the input data, allowing for dimensionality reduction and anomaly detection. Unsupervised learning has many applications in various fields, including 1. Market segmentation. Identifying groups of customers with similar behavior or characteristics can help businesses tailor their marketing strategies. 2. Fraud detection. Algorithms can be trained to identify patterns of fraudulent activity in financial data. 3. Image compression. Autoencoders can be used to reduce the dimensionality of images while preserving important information. 4. Recommendation systems. Unsupervised learning algorithms can be used to group users and items based on their preferences, leading to more accurate recommendations. 5. Natural language processing. Techniques such as topic modeling can be used to discover hidden topics or themes in large collections of text data. In conclusion, unsupervised learning is a powerful tool for discovering patterns and relationships in data without any prior knowledge of the expected output. By identifying clusters, groups, or anomalies in the data, businesses can gain valuable insights that can inform their decision-making processes. As machine learning continues to evolve, unsupervised learning is likely to play an increasingly important role in many fields. Clustering techniques in unsupervised learning. Clustering is a fundamental technique in unsupervised learning, which involves dividing a dataset into distinct groups or clusters based on similarities among data points. The main goal of clustering is to identify patterns or structure in the data that are not easily visible by other methods, such as grouping similar objects together or identifying outliers. There are several clustering techniques available, each with its own strengths and weaknesses. Some of the most popular clustering algorithms include 1. K-means clustering. This is one of the most widely used clustering techniques, which partitions the data into K clusters based on the mean distance of the data points from the centroid of each cluster. The algorithm iteratively updates the centroids and reassigns the data points to the nearest cluster. 2. Hierarchical clustering. This technique builds a hierarchy of clusters by merging or splitting existing clusters. It can be divided into two types: agglomerative clustering and divisive clustering. Agglomerative clustering starts with all data points as individual clusters, while divisive clustering starts with a single cluster and iteratively splits it into smaller subclusters. 3. DBSCAN. Density-based spatial clustering of applications with noise. This algorithm is more robust to noise and outliers than K-means, as it can identify clusters of varying densities and shapes. It partitions the data into clusters based on their density and proximity to each other. 4. K-medoids. This technique is similar to K-means, but it uses medoids, objects that are representative of their cluster, instead of centroids. Medoids can be more appropriate for categorical data or datasets with nonlinear structures. 5. Expectation maximization. M. Clustering. This algorithm is a variant of K-means that can handle missing data. It iteratively updates the parameters of the model and the cluster assignments of the data points until convergence. Applications of clustering techniques include 1. Customer segmentation. Clustering can help identify distinct customer groups with similar preferences or behaviors, enabling targeted marketing strategies. 2. Image segmentation. Clustering algorithms can group pixels in an image into regions of similar intensity or color, facilitating object recognition and image analysis. 3. Gene expression analysis. Clustering can help identify genes that are co-expressed across different samples, revealing potential biomarkers or regulatory mechanisms. 4. Anomaly detection. Clustering can identify unusual patterns in data, such as fraudulent transactions or abnormal sensor readings. 5. Recommender systems. Clustering can group users and items based on their preferences, enabling personalized recommendations. Clustering works by defining a distance metric between the data points and then grouping them into clusters based on their similarity. The distance metric can be Euclidean, for instance, k-means, or it can be more complex, such as a kernel density estimate, for instance, dbSCAN. Once the clusters are defined, the algorithm can analyze the characteristics of each cluster, such as its center, size, and shape. In conclusion, clustering techniques are powerful tools for exploring and understanding datasets. By grouping similar data points together, they can reveal hidden patterns, structures, or anomalies in the data. Depending on the application, different clustering algorithms may be more appropriate, but a thorough understanding of the underlying data is crucial to selecting the most relevant technique. Dimension reduction techniques in unsupervised learning. Dimension reduction is a fundamental aspect of unsupervised learning, as it allows for the simplification of high-dimensional datasets while preserving relevant information. This section will discuss several popular dimension reduction techniques and their role in data analysis and visualization. 1. Principal Component Analysis (PCA). PCA is one of the most widely used dimension reduction techniques. It transforms the original dataset into a lower dimensional space by identifying the principal components that explain the most variance in the data. These components are ordered based on their importance, with the first component explaining the most variance and subsequent components explaining increasingly less variance. PCA is particularly useful for visualizing high-dimensional datasets and identifying patterns that may not be apparent from a direct view of the data. 2. Linear discriminant analysis (LDA). LDA is similar to PCA but is used to reduce the dimensionality of the data while also taking into account class labels. It is particularly useful for classification tasks, as it can help identify the features that are most important for separating different classes. LDA finds a lower dimensional space that maximizes the separation between classes while minimizing the within-class scatter. 3. T-SNE. T-SNE, T-distributed stochastic neighbor embedding, is a nonlinear dimension reduction technique that preserves the local structure of the data. It is particularly useful for visualizing high-dimensional datasets with complex relationships between variables. T-SNE maps each datum to a lower dimensional space in a way that tries to preserve the relative distances between neighboring data points. 4. Autoencoders. Autoencoders are neural networks that learn to compress the input data into a lower dimensional representation and then reconstruct the original data from this representation. They are particularly useful for dimensionality reduction tasks, as they can learn complex relationships between variables. Autoencoders can be trained using an unsupervised learning approach, where the goal is to minimize the reconstruction error between the input and output data. 5. Manifold learning. Manifold learning techniques aim to find a lower dimensional representation of the data that preserves the topological structure of the original data. These techniques are particularly useful for datasets with complex relationships between variables, as they can capture nonlinear patterns in the data. Examples of manifold learning techniques include isomap and locally linear embedding (LLE). In conclusion, dimension reduction techniques play a crucial role in unsupervised learning by simplifying high-dimensional datasets while preserving relevant information. By choosing the appropriate dimension reduction technique, analysts can gain insights into complex patterns and relationships in their data. leading to improved data analysis and visualization. Practical applications of unsupervised machine learning. Unsupervised machine learning is a powerful tool that can help organizations uncover hidden patterns, relationships, and insights in their data. By using unsupervised algorithms, businesses can gain a deeper understanding of their customers, products, and operations, which can lead to improved decision-making and competitive advantage. Here are some practical applications of unsupervised machine learning. 1. Customer segmentation. Unsupervised machine learning can help organizations segment their customers based on common characteristics, such as demographics, purchasing behavior, or loyalty program participation. By analyzing customer data without preconceived notions, businesses can identify new customer segments and tailor marketing strategies to each group. 2. Product recommendation. Unsupervised machine learning algorithms can analyze a user's past purchase history and recommend products that they may be interested in buying. This can lead to increased sales and customer satisfaction. 3. Fraud detection. Unsupervised machine learning can help identify fraudulent transactions by analyzing patterns in data without any preconceived notions of what a legitimate transaction looks like. This can lead to improved security and reduced financial losses. 4. Image recognition. Unsupervised machine learning algorithms can be used to analyze images and identify patterns, such as objects or faces. This can have applications in image recognition, object detection, and facial recognition. 5. Predictive maintenance. By analyzing sensor data from machines without any preconceived notions of what a normal reading should look like, unsupervised machine learning algorithms can identify patterns that indicate when maintenance is needed. This can lead to improved equipment reliability and reduced downtime. 6. Recommender systems. Unsupervised machine learning algorithms can be used to recommend products or services based on the user's past behavior, without any preconceived notions of what they may like. This can lead to increased customer satisfaction and sales. 7. Text analysis. Unsupervised machine learning algorithms can analyze text data, such as customer feedback or social media posts, to identify patterns and sentiment. This can help businesses understand their customers' opinions and improve their products or services. 8. Anomaly detection. Unsupervised machine learning algorithms can identify unusual patterns in data that may indicate errors, fraud, or other anomalies. This can lead to improved security and reduced financial losses. 9. Clustering. Unsupervised machine learning algorithms can group similar data points together, without any preconceived notions of what the clusters should look like. This can help businesses identify new market segments or understand customer behavior better. 10. Association rule learning. Unsupervised machine learning algorithms can identify patterns in data where certain events are likely to occur together. This can lead to improved marketing strategies and increased sales. In conclusion, unsupervised machine learning is a powerful tool that can help organizations uncover hidden patterns, relationships, and insights in their data. By applying these algorithms without any preconceived notions, businesses can gain a deeper understanding of their customers, products, and operations, which can lead to improved decision-making and competitive advantage. Reinforcement learning. Reinforcement learning is a subfield of machine learning that focuses on training agents to make decisions in complex, uncertain environments. Unlike supervised learning, which involves learning from labeled data, or unsupervised learning, which involves discovering patterns in unlabeled data. Reinforcement learning involves learning through trial and error by interacting with an environment and receiving feedback in the form of rewards or penalties. The goal of reinforcement learning is to learn a policy that maps states to actions in a way that maximizes a cumulative reward signal over time. The agent learns by observing the environment, taking actions, and receiving rewards or penalties based on its actions. The process of learning is iterative, with the agent improving its policy through repeated interactions with the environment. Applications of reinforcement learning. Reinforcement learning has many applications in AI and machine learning, including 1. Robotics. Reinforcement learning can be used to train robots to perform complex tasks such as grasping and manipulation, or navigating through unstructured environments. 2. Game playing. Reinforcement learning has been used to train agents to play games such as Go, poker, and video games at a superhuman level. 3. Recommendation systems. Reinforcement learning can be used to personalize recommendations for users based on their past behavior and feedback. 4. Autonomous vehicles. Reinforcement learning can be used to train autonomous vehicles to make decisions in complex traffic scenarios, such as merging onto a busy highway or navigating through a construction zone. 5. Financial trading. Reinforcement learning can be used to train agents to make trading decisions based on market data and feedback from the environment. 6. Healthcare. Reinforcement learning can be used to optimize treatment plans for patients based on their medical history and feedback from clinical trials. 7. Education. Reinforcement learning can be used to personalize educational content for students based on their learning style and feedback from assessments. 8. Home automation. Reinforcement learning can be used to train agents to control home appliances and devices based on user preferences and feedback from the environment. 9. Customer service. Reinforcement learning can be used to train chatbots and virtual assistants to provide personalized customer service based on user interactions and feedback. 10. Sports. Reinforcement learning can be used to train agents to make decisions in sports, such as basketball, soccer, or tennis, based on game data and feedback from the environment. Challenges and limitations of reinforcement learning. While reinforcement learning has many potential applications, it also faces several challenges and limitations, including 1. Exploration-exploitation trade-off. The agent must balance exploring new actions and exploiting the most rewarding actions to maximize the cumulative reward signal. 2. Delayed rewards. In many reinforcement learning problems, rewards are not immediate but rather delayed by several time steps, making it challenging for the agent to learn an optimal policy. 3. Partial observability. The agent may not observe the entire environment, but only a partial observation of the state, making it difficult to learn an optimal policy. 4. High-dimensional state and action spaces. Many reinforcement learning problems involve high-dimensional state and action spaces, which can make learning challenging. 5. Non-stationarity. The environment may change over time, requiring the agent to adapt its policy to new conditions. 6. Safety concerns. Reinforcement learning agents must be designed to operate within safety constraints, such as avoiding dangerous states or actions. 7. Explainability and interpretability. Reinforcement learning models can be difficult to interpret and understand, making it challenging to explain their decisions to users. In conclusion, reinforcement learning is a powerful tool for training agents to make decisions in complex, uncertain environments. While it faces several challenges and limitations, It has many potential applications in AI and machine learning, including robotics, game playing, recommendation systems, autonomous vehicles, financial trading, healthcare, education, home automation, customer service, and sports. As the field continues to evolve, practical applications of reinforcement machine learning. Reinforcement learning, RL, is a subfield of machine learning that involves training agents to make decisions in complex, uncertain environments. RL has many practical applications across various industries, including 1. Robotics. RL can be used to train robots to perform tasks such as object manipulation, navigation, and control. For example, RL can be used to teach a robot to grasp and manipulate objects in a dynamic environment. 2. Autonomous vehicles. RL can be used to train autonomous vehicles to make decisions such as lane changes, merging, and avoiding obstacles. For example, RL can be used to teach an autonomous vehicle to navigate through a busy highway. 3. Recommendation systems. RL can be used to train recommendation systems to provide personalized recommendations to users based on their behavior and preferences. For example, RL can be used to train a recommendation system to suggest products to a user based on their previous purchases and browsing history. 4. Financial trading. RL can be used to train agents to make trading decisions based on market data and trends. For example, RL can be used to train an agent to buy or sell stocks based on market conditions. 5. Healthcare. RL can be used to train agents to make decisions in healthcare applications such as drug discovery, patient treatment, and medical diagnosis. For example, RL can be used to train an agent to identify potential drug targets for a specific disease based on molecular dynamics simulations. 6. Education. RL can be used to train agents to personalize learning experiences for students based on their behavior and progress. For example, RL can be used to train an agent to recommend learning materials to a student based on their previous performance and interests. 7. Manufacturing. RL can be used to train agents to optimize manufacturing processes such as quality control, inventory management, and supply chain optimization. For example, RL can be used to train an agent to predict and adjust the production schedule based on real-time data from the factory floor. 8. Energy. RL can be used to train agents to optimize energy consumption and production in applications such as smart grids and renewable energy systems. For example, RL can be used to train an agent to predict and manage energy demand and supply in a smart grid environment. 9. Security. RL can be used to train agents to detect and respond to security threats in real time. For example, RL can be used to train an agent to identify and neutralize malware attacks on a computer network. 10. Entertainment. RL can be used to train agents to generate realistic NPC, non-player character behavior in video games and virtual reality environments. For example, RL can be used to train an agent to play a game of soccer or chess at a professional level. In each of these applications, RL algorithms can learn from experience and adapt to changing conditions, leading to improved decision-making and increased efficiency. As the field of RL continues to evolve, we can expect to see even more practical applications across various industries. Generative AI, an overview. In recent years, the field of machine learning has witnessed significant advancements, with a growing focus on generative AI. Generative AI refers to the ability of machines to generate new content, such as images, videos, music, and text. This chapter will delve into the concept of generative AI and its applications in AI and machine learning. Definition of generative AI. Generative AI is a subset of artificial intelligence that involves creating novel data, rather than simply recognizing patterns in existing data. It encompasses various techniques, including 1. Generative models. These models learn the underlying distribution of the input data and generate new samples that are similar to the original data. Examples include generative adversarial networks, GANs, and variational autoencoders, VAEs. 2. Sampling techniques. These techniques involve generating new data by sampling from a predefined distribution. Examples include Markov chain Monte Carlo, MCMC, and autoregressive models. Applications of generative AI. Generative AI has numerous applications across various industries, including 1. Art. Generative AI can be used to create new forms of art, such as images, music, and poetry. 2. Data augmentation. Generative models can be used to generate new data that can be used to augment existing datasets, improving the performance of machine learning models. 3. Fake data. Generative AI can be used to create fake data, such as synthetic images or videos, which can be used to train machine learning models or to test their robustness. 4. Drug discovery. Generative models can be used to generate new molecular structures that could potentially lead to the discovery of new drugs. 5. Creative writing. Generative AI can be used to generate creative writing, such as stories or poetry, by using natural language processing techniques. 6. Robotics. Generative models can be used to generate new robotic designs that could improve the performance of robots in various tasks. 7. Virtual reality. Generative AI can be used to generate realistic virtual environments, such as landscapes or cities, for use in video games or other applications. 8. Fashion. Generative models can be used to generate new fashion designs or styles by analyzing existing patterns and trends. 9. Finance. Generative models can be used to generate synthetic financial data, such as stock prices or economic indicators, for use in risk analysis or portfolio optimization. 10. Healthcare. Generative AI can be used to generate synthetic medical images or patient data, which can be used to train machine learning models or to test their performance. Challenges and limitations of generative AI. While generative AI has immense potential, it also faces several challenges and limitations, including 1. Quality of generated data. The quality of the generated data is crucial for its usefulness in various applications. However, generating high-quality data can be a challenge, especially when dealing with complex data structures. 2. Mode collapse. Generative models often suffer from mode collapse, where they generate limited variations of the same output, rather than exploring the full range of possibilities. 3. Lack of diversity. Generative models can sometimes produce repetitive or homogeneous outputs, lacking diversity and creativity. 4. Evaluation metrics. Developing appropriate evaluation metrics for generative AI is a challenging task, as the generated data must be evaluated for both quality and relevance to the intended application. 5. Explainability. Generative models often struggle with explainability, making it difficult to understand why they are generating certain outputs or how they arrived at those conclusions. 6. Adversarial attacks. Generative models can be vulnerable to adversarial attacks, which can manipulate the generated data by introducing subtle changes that cause the model to produce incorrect results. 7. Ethical concerns. The potential misuse of generative AI raises ethical concerns, such as the generation of fake news or deepfakes, which can have significant consequences in various domains. In conclusion, generative AI is a rapidly evolving field with vast potential to transform various industries and applications. However, it also faces several challenges and limitations that must be addressed through continued research and development. As the field continues to advance, it is crucial to ensure that generative AI is developed and applied responsibly, ethically, and in a way that benefits society as a whole. Generative AI algorithms. Understanding the basics. Generative AI algorithms are a type of machine learning algorithm that can create new data or content, such as images, videos, music, and text. These algorithms use complex mathematical models to learn patterns within the data they are trained on, and then use this knowledge to generate new data that resembles the original training data. In this section, we will explore how generative AI algorithms work and provide examples of their applications. How do generative AI algorithms work? Generative AI algorithms are based on a mathematical concept called a probabilistic model. This means that the algorithm estimates the probability of each possible output or feature of data, and then uses this information to generate new data. The key to generative AI is that it can learn from a small number of training examples, allowing it to create new content that is diverse and realistic. To understand how generative AI algorithms work, let's consider an example of a simple neural network trained on images of dogs. The neural network learns the patterns in the images of dogs, such as the shape of the ears, the color of the fur, and the position of the tail. Once the network is trained, it can use this knowledge to generate new images of dogs that it has never seen before. Examples of generative AI algorithms. 1. Generative adversarial networks. GANs. GANs are a type of generative AI algorithm that consists of two neural networks, a generator and a discriminator. The generator creates new data, while the discriminator evaluates the generated data and tells the generator whether it is realistic or not. Through this process, the generator improves over time until it can create indistinguishable data from the original training data. Example: GANs have been used to generate realistic images of faces, cars, and landscapes. 2. Variational autoencoders. VAEs. VAEs are another type of generative AI algorithm that use a probabilistic model to generate new data. They consist of an encoder network that maps the input data to a probabilistic distribution, and a decoder network that generates new data from this distribution. Example: VAEs have been used to generate new images of faces, objects, and scenes by learning the patterns in a large dataset of images. 3. Transformers. Transformers are a type of neural network architecture that have been used for a variety of applications, including language translation, text generation, and image captioning. They use self-attention mechanisms to model complex relationships between different parts of input data. Example: transformers have been used to generate natural language descriptions of images by learning patterns in a large dataset of images and their corresponding captions. Conclusion: generative AI algorithms are a powerful tool for creating new data or content, such as images, videos, music, and text. By understanding how these algorithms work and the different types of models used, we can unlock their potential to create innovative applications in various industries. Whether it's generating realistic images of faces or creating natural language descriptions of images, generative AI has the potential to revolutionize the way we interact with data. Large language models, LLMs. In recent years, there has been significant advancement in the field of natural language processing, NLP, with the development of large language models, LLMs. These models have revolutionized the way we process and understand language, enabling machines to perform tasks that were previously thought to be exclusive to humans. In this chapter, we will delve into the significance and applications of LLMs in NLP. What are large language models? LLMs are neural network-based models that are trained on vast amounts of text data to learn patterns and structures of language. These models can process and generate language at unprecedented scales, making them particularly useful for tasks such as language translation, text summarization, and language generation. The key characteristic of LLMs is their size, with some models containing billions of parameters and trillions of weights. Significance of large language models. The significance of LLMs lies in their ability to capture the complexities of language, enabling them to perform tasks that were previously thought to be exclusive to humans. Some of the key applications of LLMs include: 1. Language translation. LLMs can translate languages with high accuracy, allowing for more efficient and cost-effective translation services. 2. Text summarization. LLMs can summarize long documents and articles, saving time and improving comprehension. 3. Language generation. LLMs can generate coherent and contextually relevant text, enabling applications such as chatbots and language assistants. 4. Sentiment analysis. LLMs can analyze text to determine the sentiment and emotions behind it, providing valuable insights for businesses and organizations. 5. Named entity recognition. LLMs can identify and classify named entities in text, such as people, places, and organizations. Applications of large language models. LLMs have numerous applications across various industries, including but not limited to: 1. Healthcare. LLMs can analyze medical texts to identify patterns and trends, improving diagnosis and treatment outcomes. 2. Finance. LLMs can analyze financial texts to identify market trends and make investment decisions. 3. Education. LLMs can analyze educational texts to personalize learning experiences for students. 4. Marketing. LLMs can analyze customer feedback and reviews to improve marketing strategies. 5. Legal. LLMs can analyze legal texts to identify relevant cases and statutes, improving the efficiency of legal professionals. Challenges and limitations of large language models. While LLMs have revolutionized the field of NLP, they are not without their challenges and limitations. Some of the key challenges include: 1. Training time. Training LLMs requires significant computational resources and time. 2. Data quality. The quality of the training data can significantly impact the performance of LLMs. 3. Bias. LLMs can perpetuate biases present in the training data, leading to unfair or discriminatory outcomes. 4. Explainability. LLMs can be difficult to interpret and understand, making it challenging to explain their decisions and actions. 5. Ethical concerns. The use of LLMs raises ethical concerns, such as the potential for misuse or manipulation. Conclusion. Large language models have transformed the field of NLP, enabling machines to perform tasks that were previously thought to be exclusive to humans. While these models have numerous applications across various industries, they also present challenges and limitations that must be addressed. As the use of LLMs continues to grow, it is essential to ensure their responsible development and deployment to maximize their potential, while minimizing their risks. Large language models, LLMs, and their contributions. In recent years, there has been significant progress in the field of natural language processing, NLP, thanks to the development of large language models, LLMs. These models have shown remarkable capabilities in understanding and generating human-like language, making them valuable tools for a wide range of applications. In this section, we will discuss some of the most popular LLMs, including GPT-3, BERT, and their contributions to language understanding and generation tasks. 1. Generative Pre-trained Transformer 3. GPT-3. GPT-3 is a state-of-the-art LLM developed by Openai that has achieved unprecedented results in various NLP tasks. GPT-3 is trained on a massive dataset of text from the internet and is capable of generating coherent and often realistic text, including articles, stories, and even entire books. Its architecture is based on a transformer model, which allows it to process input sequences of arbitrary length and generate output sequences of arbitrary length as well. GPT-3's ability to generate long sequences of coherent text has led to its use in applications such as content creation, chatbots, and language translation. 2. BERT. Bidirectional encoder representations from transformers. BERT is another popular LLM developed by Google that has achieved impressive results in a wide range of NLP tasks. Unlike GPT-3, which generates text from scratch, BERT is trained to predict the missing word in a sentence based on its context. This allows it to be fine-tuned for specific tasks such as sentiment analysis, question answering, and language translation. BERT's ability to capture the context of a sentence has made it an essential tool for many NLP applications. 3. Contributions to language understanding and generation tasks. Both GPT-3 and BERT have contributed significantly to various NLP tasks, including but not limited to text classification. Both models have achieved high accuracy in text classification tasks such as sentiment analysis, spam detection, and topic modeling. Question answering. GPT-3 has been used to generate answers to complex questions, while BERT has been fine-tuned for specific question answering tasks with impressive results. Language translation. Both models have been used to translate text from one language to another with high accuracy. Summarization. GPT-3 has been used to summarize long documents and articles, while BERT has been fine-tuned for specific summarization tasks with impressive results. 4. Limitations and future directions. Despite their impressive capabilities, LLMs such as GPT-3 and BERT have some limitations that must be addressed in future research. Some of these limitations include lack of common sense. Both models often generate text that lacks common sense or is nonsensical when taken out of context. Limited domain knowledge. GPT-3 and BERT are typically trained on large datasets from the internet, which can limit their ability to understand domain-specific language and concepts. Difficulty in controlling style and tone. Both models can generate text that lacks coherence or consistency in terms of style and tone. In conclusion, LLMs such as GPT-3 and BERT have revolutionized the field of NLP by providing powerful tools for language understanding and generation tasks. However, there are still limitations to their capabilities, and future research should focus on addressing these limitations and improving their performance in various applications. Applications of popular large language models. LLMs. Large language models, LLMs, have revolutionized the field of natural language processing in recent years. These models have been trained on vast amounts of text data and have demonstrated incredible abilities to generate text, answer questions, and even create new content. As a result, LLMs have numerous applications across various industries, including but not limited to 1. Language translation. LLMs can be used to improve language translation systems by generating more accurate and fluent translations. By training these models on large datasets of translated text, they can learn to recognize patterns and nuances in language, enabling them to generate higher quality translations. 2. Text summarization. LLMs can be used to summarize long documents or articles by generating a concise summary of the main points. This application is particularly useful for news organizations, researchers, and students who need to quickly understand the gist of a large document without reading the entire thing. 3. Chatbots and virtual assistants. LLMs can be used to create more sophisticated chatbots and virtual assistants that can understand and respond to complex user queries. By training these models on large datasets of customer service interactions, they can learn to recognize patterns in language use and generate more accurate and helpful responses. 4. Content generation. LLMs can be used to generate new content, such as articles, blog posts, or social media updates. This application is particularly useful for businesses and organizations that need to produce a high volume of content without breaking the bank on human writers. 5. Sentiment analysis. LLMs can be used to analyze text data and determine the sentiment behind it. This application is particularly useful for marketing and advertising companies who want to understand how customers are reacting to their campaigns and make informed decisions based on that data. 6. Language understanding. LLMs can be used to improve language understanding systems by generating more accurate and nuanced interpretations of text. By training these models on large datasets of text, they can learn to recognize patterns in language use and generate more accurate results. 7. Text generation for accessibility. LLMs can be used to generate text for accessibility purposes, such as generating alt text for images or transcribing videos into text. This application is particularly useful for individuals with disabilities who need assistance accessing visual content. 8. Improving language learning. LLMs can be used to improve language learning systems by generating more accurate and personalized language lessons. By training these models on large datasets of text, they can learn to recognize patterns in language use and generate more effective language learning materials. 9. Enhancing legal document analysis. LLMs can be used to enhance the analysis of legal documents by generating more accurate and nuanced interpretations of text. By training these models on large datasets of legal texts, they can learn to recognize patterns in language use and generate more accurate results. 10. Improving customer service. LLMs can be used to improve customer service systems by generating more accurate and personalized responses to customer queries. By training these models on large datasets of customer interactions, They can learn to recognize patterns in language use and generate more effective customer service solutions. In conclusion, the applications of popular large language models, LLMs, are vast and diverse. These models have the potential to revolutionize numerous industries by generating more accurate and personalized text output. As the technology continues to evolve, we can expect to see even more innovative applications of LLMs in the future. Openai, pioneering artificial intelligence for the greater good. Openai is a non-profit artificial intelligence research organization founded in 2016 by a group of leading AI researchers, including Elon Musk, Sam Altman, and Ilya Sutskever. The organization's mission is to ensure that artificial intelligence, AI, is developed in a way that benefits humanity and aligns with our values. Openai's work focuses on developing and advancing the field of machine learning, with a particular emphasis on creating AI systems that are safe, transparent, and controllable. Significance of Openai. Openai has significantly contributed to the development and understanding of machine learning algorithms, including deep learning techniques. The organization's research has led to breakthroughs in areas such as computer vision, natural language processing, and robotics. Openai's work has also helped to advance the field of reinforcement learning, which is critical for developing AI systems that can learn from their environment and make decisions based on that learning. Contributions of Openai. Openai has made several significant contributions to the field of machine learning, including 1. Development of the deep learning algorithm. Openai has been instrumental in the development of the deep learning algorithm, which is a type of machine learning algorithm that is capable of learning and improving on its own by analyzing large amounts of data. This algorithm has been used in a variety of applications, including image recognition, natural language processing, and autonomous driving. 2. Introduction of the Generative Adversarial Network (GAN). Openai introduced the concept of the Generative Adversarial Network (GAN), which is a type of machine learning algorithm that can generate new data that resembles existing data. This has led to significant advancements in areas such as computer graphics and image synthesis. 3. Development of the reinforcement learning algorithm. Openai has made significant contributions to the development of the reinforcement learning algorithm, which is a type of machine learning algorithm that learns from its environment and makes decisions based on that learning. This algorithm has been used in applications such as robotics and autonomous driving. 4. Advocacy for responsible AI. Openai has been a vocal advocate for responsible AI, calling for the development of AI systems that are safe, transparent, and controllable. The organization has also launched initiatives to promote diversity and inclusion in the field of AI research. Impact of Openai on the field of machine learning. Openai's contributions have had a significant impact on the field of machine learning, leading to advancements in areas such as computer vision, natural language processing, and robotics. The organization's work has also helped to promote the development of responsible AI systems that align with human values. Openai's advocacy for diversity and inclusion in the field of AI research has helped to ensure that the benefits of AI are shared by a diverse group of people. Conclusion. Openai is a pioneering organization in the field of artificial intelligence, with a focus on developing safe, transparent, and controllable machine learning systems. The organization's contributions have had a significant impact on the field, leading to advancements in areas such as computer vision, natural language processing, and robotics. OpenAI's advocacy for responsible AI has helped to ensure that the benefits of AI are shared by a diverse group of people, and its commitment to promoting diversity and inclusion in the field of AI research is crucial for the future of the field. Innovations in AI technology by OpenAI. OpenAI is a non-profit artificial intelligence research organization that has made significant contributions to the field of AI. Founded in 2016 by Elon Musk, Greg Gottesman, and Ilya Sutskever, among others, OpenAI's mission is to ensure that AI is developed in a responsible and ethical manner. To achieve this goal, the organization has developed several innovative products and initiatives that aim to advance the field of AI while addressing its potential risks and challenges. One of OpenAI's most notable achievements is the development of GPT-3, Generative Pre-trained Transformer 3, a language model that has reached unprecedented levels of performance in various natural language processing tasks. GPT-3 is capable of generating text, summarizing articles, and even creating new and coherent sentences, all while maintaining a consistent style and tone. This technology has the potential to revolutionize content creation, from writing articles and books to developing chatbots and virtual assistants. Another significant innovation by OpenAI is DALL-E, a text-to-image model that can generate high-quality images based on text descriptions. DALL-E's ability to create realistic and diverse images has far-reaching implications for industries such as advertising, entertainment, and e-commerce. For instance, it could be used to generate product images for an online store or create visually engaging content for social media platforms. In addition to these impressive technologies, OpenAI has also developed several other innovative AI solutions. For example, the organization has created a tool called Wildfire, which can identify and mitigate potential safety risks in AI systems. This is crucial in ensuring that AI systems are used responsibly and do not pose any danger to humans or the environment. OpenAI has also launched several initiatives aimed at promoting transparency, accountability, and ethical use of AI. One such initiative is the Openai 5, a set of guidelines designed to help developers build safe and beneficial AI systems. These guidelines cover topics such as data privacy, algorithmic transparency, and human oversight, providing a framework for responsible AI development. In conclusion, OpenAI's innovative products and initiatives have the potential to transform various industries and aspects of society. By developing technologies that are both advanced and ethical, OpenAI is helping to shape the future of AI while ensuring its responsible use. As AI continues to evolve and expand into new areas, organizations like OpenAI will play a critical role in shaping its development and use for the betterment of society as a whole. Capabilities and applications of ChatGPT. ChatGPT is a highly advanced AI language model developed by OpenAI that has demonstrated remarkable capabilities in natural language understanding and generation. Developed using a combination of deep learning techniques and large-scale data, ChatGPT is capable of understanding and responding to complex queries and tasks with unprecedented accuracy and fluidity. One of the standout capabilities of ChatGPT is its ability to understand and generate human-like language. Unlike traditional AI models that rely on predefined templates or rules-based systems, ChatGPT can respond to questions and prompts in a way that mimics human conversation. This is achieved through the use of complex neural networks that are trained on vast amounts of text data, allowing ChatGPT to learn patterns and relationships in language use. In addition to natural language understanding and generation, ChatGPT has numerous applications across various industries. Here are some examples. 1. Customer service. ChatGPT can be used to create chatbots that can handle customer inquiries and provide personalized responses. By analyzing customer feedback and preferences, ChatGPT can learn to tailor its responses to better meet customer needs. 2. Content creation. With its ability to generate human-like language, ChatGPT can be used to create high-quality content quickly and efficiently. This can be particularly useful for businesses that need a lot of content, such as blogs, articles, or social media posts. 3. Language translation. ChatGPT can be fine-tuned to translate languages, allowing it to help break down language barriers and improve communication between people who speak different languages. 4. Writing assistance. ChatGPT can assist writers by providing suggestions for sentence structure, grammar, and style. This can help writers to improve the quality of their work and save time in the writing process. 5. Conversational AI. ChatGPT can be used to create conversational AI systems that can understand and respond to user queries in a natural and intuitive way. This has numerous applications, including virtual assistants, language learning tools, and chatbots for customer service. 6. Text summarization. ChatGPT can summarize long pieces of text into shorter, more digestible versions. This can be useful for businesses that need to quickly summarize large amounts of data or information. 7. Sentiment analysis. ChatGPT can analyze text to determine the sentiment and emotions behind it. This can be useful for businesses that want to understand how their customers are feeling about them or a particular product or service. 8. Dialogue generation. ChatGPT can generate coherent and contextually relevant dialogue, allowing it to create conversations that feel natural and authentic. This has numerous applications, including creating realistic NPCs, non-player characters, in video games or virtual assistants that can engage in natural-sounding conversations. 9. Text generation. ChatGPT can generate text on a given topic or subject. This can be useful for businesses that need to create large amounts of content quickly, such as blog posts, articles, or social media updates. 10. Creative writing. ChatGPT can assist creative writers by generating ideas, plot points, and character insights. This can help writers overcome writer's block or generate new ideas for their work. In conclusion, ChatGPT is a highly advanced AI language model with numerous capabilities and applications across various industries. Its ability to understand and generate human-like language makes it an invaluable tool for businesses looking to improve their communication and content creation processes. Openai models and their significance in AI development. Openai is a non-profit artificial intelligence research organization that has been at the forefront of developing innovative AI models and algorithms. The organization has developed several open-source models that have revolutionized the field of AI, including deep learning, reinforcement learning, and generative models. In this section, we will discuss the various Openai models and their significance in the development of AI applications, including their usage and impact in the industry. 1. Deep learning models. Openai has developed several deep learning models that have shown remarkable performance in image classification, natural language processing, and speech recognition tasks. The most notable model is the Generative Adversarial Network (GAN), which is a two-player game framework that can generate realistic images videos, and music. GUNs have been used in various applications, including video game design and medical imaging. 2. Reinforcement learning models. Reinforcement learning models are designed to learn from interactions with an environment. Openai has developed several reinforcement learning models that can learn complex tasks, such as playing games like Go and StarCraft, and controlling robots for tasks like cooking and cleaning. These models have shown great potential in developing autonomous AI systems that can interact with their environments. 3. Generative models. Generative models are designed to generate new data samples that resemble the training data. Openai has developed several generative models, including the popular Generative Adversarial Network (GAN) and Variational Autoencoder (VAE). These models have been used in applications such as image and video synthesis, text generation, and style transfer. 4. Transformers. Transformers are a type of deep learning model that is particularly well suited for natural language processing tasks. Openai has developed several transformer-based models that have shown remarkable performance in tasks such as language translation, question answering, and text summarization. These models have been widely adopted in the industry and have contributed significantly to the advancement of AI research. 5. Robotics models. Openai has also developed several robotics models that can learn complex motor skills, such as grasping and manipulation tasks. These models have shown great potential in developing autonomous robots that can interact with their environments. Impact and usage in the industry. The Openai models have had a significant impact on the industry, driving innovation and advancement in various fields of AI research. The GAN model, for example, has been widely adopted in the field of computer vision, enabling realistic image synthesis and manipulation. The transformer-based models have revolutionized natural language processing tasks, enabling faster and more accurate language translation and question answering systems. The reinforcement learning models have shown great potential in developing autonomous AI systems that can interact with their environments. In conclusion, Openai has made significant contributions to the field of AI research through its development of innovative models and algorithms. These models have had a profound impact on the industry, driving innovation and advancement in various fields of AI research. As the field of AI continues to evolve, it is likely that Openai will continue to play a major role in shaping its future. Llama 2 Meta AI. Llama 2 is a groundbreaking advancement in the field of artificial intelligence, AI, and machine learning. Milliliter. Developed by researchers at Meta AI. This innovative technology represents a significant leap forward in the capabilities of milliliter models. In this chapter, we will delve into the significance and innovations brought by Llama 2, exploring its potential applications and the implications it has on the future of AI and milliliter. Significance of Llama 2. Llama 2 is a meta-learning algorithm that learns how to learn by leveraging the strengths of both supervised and unsupervised learning. Llama 2 can adapt to new tasks with minimal additional training data. This makes it an incredibly versatile tool in the milliliter arsenal, capable of tackling complex problems with ease. Innovations of Llama 2. Llama 2 introduces several novel innovations that set it apart from existing milliliter models. Some of these include: 1. Meta-learning. Llama 2 is designed to learn how to learn, allowing it to adapt quickly to new tasks and datasets. This makes it an ideal choice for real-world applications where data is constantly changing or evolving. 2. Hierarchical reinforcement learning. Llama 2 uses a hierarchical reinforcement learning framework to learn complex behaviors from scratch. This allows it to solve problems that would otherwise require extensive domain-specific knowledge. 3. Transfer learning. Llama 2 can transfer knowledge from one task to another, significantly reducing the amount of training data required for a new task. This makes it an effective tool for solving tasks with limited data availability. 4. Sparse representation. Llama 2 uses a sparse representation to learn and represent complex patterns in the data. This allows it to generalize better to new tasks and datasets, making it more robust and reliable. Potential applications of Llama 2. The potential applications of Llama 2 are vast and varied. Some possible uses include: 1. Robotics. With its ability to adapt quickly to new tasks and environments, Llama 2 could be used to improve the performance of robots in a variety of settings, such as manufacturing, logistics, or search and rescue operations. 2. Healthcare. Llama 2 could be applied to medical diagnosis and treatment, enabling doctors to make more accurate predictions and prescribe more effective treatments. 3. Finance. With its ability to learn from limited data, Llama 2 could be used to improve the accuracy of financial predictions and risk assessments, helping investors make better informed decisions. 4. Education. Llama 2 could revolutionize the way we teach and learn, enabling students to adapt and learn more quickly in a rapidly changing educational landscape. Conclusion. Llama 2 is a groundbreaking advancement in the field of artificial intelligence and machine learning. Its ability to learn how to learn, adapt quickly to new tasks, and transfer knowledge between tasks make it an incredibly versatile tool with vast potential. Applications. As the field of AI and milliliter continues to evolve, Llama 2 is sure to play a significant role in shaping its future. Innovations and applications of Meta AI. Meta AI has been at the forefront of AI research and development, pushing the boundaries of what is possible with this technology. The company has created a range of innovative products and initiatives that have the potential to revolutionize various industries. Here are some of the most notable examples. 1. Meta AI Assistant. This is an intelligent personal assistant powered by artificial intelligence, designed to learn users' preferences and habits over time. It can perform a variety of tasks such as scheduling appointments, sending messages, making recommendations, and more. 2. AI-powered health diagnostics. Meta AI has developed advanced AI algorithms that can analyze medical images, patient data, and other health metrics to provide accurate diagnosis and treatment plans. This technology has the potential to improve healthcare outcomes and make it more accessible to underserved communities. 3. Natural language processing. NLP. Meta AI's NLP capabilities allow for advanced text analysis, sentiment detection, and language translation. These features can be applied to a wide range of industries such as customer service, marketing, and education. 4. Computer vision. Meta AI has developed advanced computer vision algorithms that can analyze images and videos, recognize objects and patterns, and even generate new images. This technology has applications in fields such as security, transportation, and entertainment. 5. Robotics and automation. Meta AI's robotics and automation initiatives aim to create machines that can perform tasks independently, without the need for human intervention. These machines can be used in manufacturing, logistics, and other industries where efficiency and productivity are key. 6. Generative models. Meta AI has developed advanced generative models that can create realistic images, videos, and music. These models have the potential to revolutionize the entertainment industry and create new forms of artistic expression. 7. Reinforcement learning. This is a type of machine learning that involves training AI systems to make decisions based on rewards or penalties. Meta AI's reinforcement learning initiatives aim to create AI systems that can learn from their mistakes and improve over time. 8. Explainable AI. XAI. This is a new area of research that focuses on developing AI systems that can provide clear explanations for their decisions. Meta AI's XAI initiatives aim to create more trustworthy and transparent AI systems that can be used in industries such as healthcare and finance. 9. Edge AI. With the increasing amount of data being generated by IoT devices, Meta AI is working on developing edge AI algorithms that can process data closer to the source, reducing latency and improving real-time decision-making capabilities. 10. Quantum AI. Meta AI is also exploring the potential of quantum computing for AI applications. By leveraging the power of quantum computers, Meta AI aims to develop new algorithms that can solve complex problems that are currently unsolvable with classical computers. These are just a few examples of the many innovative products and initiatives developed by Meta AI. As the field of AI continues to evolve, it is likely that we will see even more exciting developments from this company in the years to come. Llama 2 models and their impact on AI development. The advent of Llama 2 models has significantly advanced the field of artificial intelligence, AI. These models have had a profound impact on the development of sophisticated AI applications, contributing to the AI landscape in several ways. In this section, we will explore the two Llama models, their features, and how they have influenced the evolution of AI. 1. Llama 2.0 model. The original Llama model was introduced in 2019. And since then, several improvements have been made to create Llama 2.0. This updated model boasts enhanced capabilities, such as improved performance, faster training times, and better generalization. The Llama 2.0 model has a broader range of applications than its predecessor, including image and text classification, natural language processing, and recommender systems. Impact on AI development. The Llama 2.0 model has significantly expanded the scope of AI research and applications. Its faster training times and improved performance have enabled developers to create more complex AI systems that can tackle intricate tasks with greater accuracy and efficiency. This advancement has led to new applications in areas such as healthcare, finance, and education, where AI is being increasingly used to improve outcomes. 2. Llama 3 model. Released in 2022. The Llama 3 model represents a significant leap forward in AI technology. This latest iteration features even faster training times, improved accuracy, and enhanced capabilities such as multimodal learning, i.e., processing and analyzing multiple forms of data simultaneously. Impact on AI development. The Llama 3 model has revolutionized the field of AI by enabling the development of even more sophisticated applications. For instance, it has enabled the creation of AI systems capable of analyzing and processing vast amounts of multimodal data, such as images, text, and audio, in real time. This has opened up new possibilities for applications in areas like medical diagnosis, financial analysis, and entertainment. In conclusion, the Llama 2 models have had a profound impact on the development of advanced AI applications. expanding their capabilities and enabling the creation of more complex systems as these models continue to evolve. They will undoubtedly drive further innovation in the field of AI, leading to new and exciting applications that can improve our lives in countless ways. The Hugging Face AI Community. The Hugging Face AI community is a vibrant and innovative group of individuals who are passionate about artificial intelligence and machine learning. This community is made up of researchers, developers, and enthusiasts from all over the world who share knowledge, ideas, and code to advance the field of AI and milliliter. The Hugging Face community was founded in 2018 by a group of researchers at Google who recognized the need for a platform where individuals could collaborate and share resources more easily. Since its inception, the community has grown exponentially, with thousands of members from academia, industry, and government joining forces to tackle some of the most pressing challenges in AI and milliliter. One of the key features of the Hugging Face community is its collaborative nature. Members share code, data, and knowledge through a variety of channels, including GitHub repositories, Slack channels, and online forums. This open sharing of resources has led to countless innovations and breakthroughs in the field, as well as a sense of camaraderie and shared purpose among members. Another important aspect of the Hugging Face community is its focus on interdisciplinary collaboration. Members come from a wide range of backgrounds, including computer science, neuroscience, psychology, and more. These diverse perspectives and expertise have led to novel approaches and solutions that would not be possible in a traditional academic or industry setting. The Hugging Face community has also been instrumental in promoting diversity and inclusion within the field of AI and milliliter, by providing a platform for underrepresented groups to connect, share knowledge, and collaborate. The community is helping to level the playing field and create more opportunities for individuals from all backgrounds to contribute to the field. In addition to its core mission of collaboration and innovation, the Hugging Face community has also been involved in a number of high-profile initiatives and projects. For example, the community has contributed to the development of the popular Transformers language model, and has played a key role in the creation of the PyTorch and TensorFlow open-source frameworks. Overall, the Hugging Face AI community is a testament to the power of collaboration and shared knowledge in advancing the field of artificial intelligence and machine learning. Its focus on interdisciplinary collaboration, diversity and inclusion, and innovation has made it an essential part of the global AI ecosystem, and will continue to play a key role in shaping the future of AI and milliliter for years to come. Popular products and initiatives by Hugging Face AI. Hugging Face AI is a leading organization in the field of natural language processing, NLP, with a wide range of products and initiatives that have made significant contributions to the NLP community. Here are some of the most popular products and initiatives developed by Hugging Face AI. 1. Transformers. One of the most well-known and widely used libraries in NLP. Transformers provides a variety of pre-trained models for tasks such as language translation, language modeling, and text classification. The library has been instrumental in popularizing the use of transformer-based models in NLP. 2. BERT. Developed by Hugging Face AI. BERT, bidirectional encoder representations from transformers, is a pre-trained language model that has achieved state-of-the-art results on a wide range of NLP tasks. BERT uses a multi-layer bidirectional transformer encoder to generate contextualized representations of words in a sentence, which can be fine-tuned for specific downstream tasks. 3. Roberta. A variant of BERT. Roberta, robustly optimized BERT pre-training approach, is a pre-trained language model that was specifically designed for text classification tasks. Roberta has achieved state-of-the-art results on a number of text classification benchmarks. 4. DistilBERT. A smaller and more efficient variant of BERT. DistilBERT. DistilBERT is designed to achieve similar performance to BERT while requiring fewer computational resources. This makes it an attractive option for deploying BERT-based models on lower resource devices. 5. Hugging Face Transformers. This library provides a wide range of pre-trained transformer-based models for NLP tasks, including language translation, language modeling, and text classification. The models are trained on a variety of datasets and can be fine-tuned for specific downstream tasks. 6. Model cards. Hugging Face AI has also developed a series of model cards that provide detailed information about the performance of various NLP models on different datasets. These model cards can be used to compare the performance of different models and to choose the best one for a particular task. 7. The NLP Book. This online resource provides a comprehensive introduction to NLP, including topics such as text preprocessing, feature extraction, and machine learning. The book is intended for both beginners and experienced practitioners in the field. 8. Hugging Face Spaces. This platform provides a variety of tools and resources for working with NLP models, including pre-trained models, model cards, and tutorials on how to use the models. 9. The Hugging Face Model Hub. This is an online hub that provides a central location for accessing and comparing various NLP models. The hub includes information about the performance of each model on different datasets and allows users to easily compare and contrast different models. 10. Hugging Face's Research and Development. Hugging Face AI is constantly working on new research and development in the field of NLP, including the development of new pre-trained models and libraries, as well as collaboration with other organizations in the field to advance the state-of-the-art in NLP. In conclusion, Hugging Face AI has made significant contributions to the field of NLP through its products and initiatives. The organization's focus on developing and sharing pre-trained models and libraries has helped to advance the field and make NLP more accessible to practitioners and researchers around the world. Models and libraries from Hugging Face AI. Hugging Face AI is a popular open-source library for natural language processing (NLP) that provides a wide range of pre-trained models and libraries for various NLP tasks. These models and libraries have been widely adopted in the AI community due to their ease of use, high performance, and versatility. In this section, we will explore some of the most commonly used models and libraries from Hugging Face AI, their applications, and their significance in the AI community. 1. Transformers. Transformers are a class of deep learning models introduced by Vaswani et al. 2017. In the paper, Attention is All You Need, they have revolutionized the field of NLP by providing a simple and efficient way to process sequential data. Hugging Face AI provides several pre-trained transformer models, including BERT, Roberta, and XLNet, which have achieved state-of-the-art results in various NLP tasks such as language translation, question answering, and text classification. 2. BERT. Bidirectional encoder representations from transformers is a pre-trained transformer model that has achieved unparalleled success in many NLP tasks. It was introduced by Google in 2018 and has since become the standard for many NLP applications. BERT uses a multi-layer bidirectional transformer encoder to generate contextualized representations of words in a sentence, which can be fine-tuned for specific NLP tasks such as sentiment analysis or question answering. 3. Roberta. Robustly optimized BERT pre-training approach is a variant of BERT that was introduced by Facebook AI in 2019. It improves upon BERT by using a different training approach, which leads to better performance on some NLP tasks. Roberta has achieved state-of-the-art results in many NLP tasks such as text classification and sentiment analysis. 4. XLNet. XLNet is a pre-trained transformer model introduced by Google in 2019. It improves upon BERT and Roberta by using a new training approach that allows it to learn more complex contextual relationships between words in a sentence. XLNet has achieved state-of-the-art results in many NLP tasks such as language translation and question answering. 5. Other libraries. In addition to the transformer models, Hugging Face AI also provides other libraries for various NLP tasks such as named entity recognition, NER, sentiment analysis, and question answering. These libraries are built on top of the transformer architecture and provide a simple way to integrate them into various NLP applications. Significance in the AI community. The models and libraries from Hugging Face AI have had a significant impact on the AI community due to their ease of use, high performance, and versatility. They have democratized access to state-of-the-art NLP models, making it possible for researchers and developers without extensive knowledge of deep learning to build advanced NLP systems. The popularity of these models has also led to the development of new architectures and techniques that build upon or extend them, further advancing the field of NLP. In conclusion, Hugging Face AI provides a wide range of pre-trained models and libraries for various NLP tasks, which have been widely adopted in the AI community due to their ease of use, high performance, and versatility. The transformer models, including BERT, Roberta, and XLNet, have revolutionized the field of NLP by providing a simple and efficient way to process sequential data. Other libraries provided by Hugging Face AI, such as those for named entity recognition, sentiment analysis, and question answering, further expand the capabilities of these models. The popularity of these models has had a significant impact on the AI community, democratizing access to state-of-the-art NLP systems and leading to the development of new architectures and techniques that build upon or extend them. The Langchain framework in natural language processing and AI development. The Langchain framework is a novel approach to natural language processing, NLP, and artificial intelligence, AI, development that has gained significant attention in recent years. Developed by researchers at the University of California, Berkeley, Langchain is designed to facilitate the creation of complex NLP systems by combining multiple machine learning models into a single, unified framework. In this chapter, we will explore the Langchain framework and its role in NLP and AI development. Background and history of Langchain. The Langchain framework was first introduced in a research paper published in 2018 by a team of researchers led by Justin D. Lohr and Jacob A. Fisher. The authors proposed Langchain as a novel approach to NLP that leverages the strengths of multiple machine learning models to create more accurate and robust NLP systems. Since its introduction, Langchain has been widely adopted in the NLP community and has been used in various applications. such as language translation, text summarization, and question answering. Key components of Langchain. The Langchain framework consists of 3 key components. 1. A feature extraction module. 2. A chain of machine learning models. And 3. An output fusion module. Each component plays a crucial role in the overall performance of the Langchain framework. 1. Feature extraction module. The feature extraction module is responsible for extracting relevant features from the input data. These features are then fed into the chain of machine learning models, which we will discuss next. 2. Chain of machine learning models. The chain of machine learning models is the core component of Langchain. This consists of multiple models, each with its own strengths and weaknesses. By combining these models in a particular way, Langchain can create more accurate and robust NLP systems. 3. Output fusion module. Features and capabilities of Langchain framework. Langchain is an open-source framework designed to facilitate natural language processing (NLP) tasks across multiple languages. Developed by researchers at the University of Colorado Boulder, this framework aims to provide a unified platform for NLP tasks, allowing users to easily integrate and execute various NLP algorithms across different languages. In this section, we will discuss the features and capabilities of Langchain, its applications in AI and NLP, and the advantages it offers over traditional NLP approaches. Features and capabilities. 1. Multilingual support. Langchain's core strength lies in its ability to handle multiple languages simultaneously. It supports a wide range of languages, including popular ones like English, Spanish, French, Chinese, Arabic, and many others. This feature makes Langchain an ideal choice for NLP tasks that involve processing data in diverse languages. 2. Modular architecture. Langchain's modular architecture allows users to easily integrate and execute various NLP algorithms across different languages. This modularity enables researchers to focus on specific NLP tasks without worrying about underlying language-specific implementation details. 3. Support for multiple data sources. Langchain can handle multiple data sources simultaneously, including text data, audio data, and video data. This feature makes it a versatile tool for NLP tasks that involve processing diverse types of data. 4. Efficient processing. Langchain is designed to be computationally efficient, allowing users to process large datasets in a timely manner. Its parallel processing capabilities make it well suited for distributed computing environments. 5. Scalability. Langchain is highly scalable, enabling users to handle massive datasets with ease. This feature is particularly useful for NLP tasks that involve processing vast amounts of data, such as machine translation or text summarization. Applications in AI and NLP. 1. Machine translation. Langchain's multilingual support and efficient processing capabilities make it an ideal choice for machine translation tasks. Researchers can use Langchain to train machine learning models on large datasets, then execute these models across multiple languages to generate high-quality translations. 2. Text summarization. Langchain's ability to handle multiple data sources and its scalability make it a great tool for text summarization tasks. Researchers can use Langchain to process large texts and extract the most important information, generating concise summaries in various languages. 3. Sentiment analysis. Langchain's modular architecture and support for multiple data sources enable researchers to build sentiment analysis models that can handle diverse types of text data. This feature is particularly useful for tasks that involve processing text data from social media platforms or online reviews. 4. Named Entity Recognition (NER). Langchain's ability to process text data efficiently and its support for multiple languages make it an ideal tool for named entity recognition tasks. Researchers can use Langchain to identify and classify entities such as names, locations, and organizations across different languages. Advantages over traditional NLP approaches. 1. Faster development. Langchain's modular architecture and support for multiple data sources streamline the development process for NLP tasks, reducing the time and effort required to build and train models. 2. Improved accuracy. Langchain's ability to handle diverse languages and data sources leads to more accurate NLP models, as they can learn from a broader range of data. 3. Increased scalability. Langchain's parallel processing capabilities make it easier to scale NLP tasks to handle large data sets, leading to improved performance and faster development times. 4. Better adaptability. Langchain's modular architecture allows researchers to adapt their NLP models to different languages and data sources more easily, making it a versatile tool for various applications. In conclusion, Langchain is a powerful framework that offers numerous advantages over traditional NLP approaches. Its multilingual support, modular architecture, efficient processing capabilities, scalability, and adaptability make it an ideal choice for NLP tasks that involve handling diverse languages and data sources. As the field of AI and NLP continues to evolve, Langchain is poised to play a significant role in advancing these technologies across multiple domains. Real-world use cases of Langchain framework. Langchain, a powerful open-source framework for natural language processing (NLP), has been gaining traction in recent years due to its versatility and adaptability. The framework has been successfully applied in various real-world use cases, demonstrating its potential in natural language understanding, generation, and AI development. Here are some of the most exciting applications of Langchain. 1. Sentiment analysis. Langchain has been used to develop a sentiment analysis tool for analyzing customer feedback on social media platforms. The tool is able to identify both positive and negative sentiments in customer reviews, enabling businesses to respond appropriately and improve their customer service. 2. Language translation. Langchain has been applied to develop a machine translation system that can translate between multiple languages. The system is able to handle complex language structures and idiomatic expressions, making it an effective tool for international communication. 3. Text summarization. Langchain has been used to create a text summarization tool that can condense long documents into concise summaries. This tool has been particularly useful in legal and financial domains where summarizing large amounts of text is crucial for decision making. 4. Chatbots. Langchain has been applied to develop chatbots that can engage with customers in a conversational manner. These chatbots are able to understand natural language inputs and respond appropriately, enhancing customer experience and reducing the workload of human customer support agents. 5. Content generation. Langchain has been used to generate high-quality content for websites, blogs, and social media platforms. The framework is able to produce coherent and contextually relevant text, making it an attractive solution for content creators looking to automate their content production process. 6. Language modeling. Langchain has been applied to build language models that can understand and generate natural Language text. These models have been used in various applications such as language translation, text summarization, and chatbots. 7. Named entity recognition. Langchain has been used to develop a named entity recognition tool that can identify and classify entities in unstructured text. This tool has been applied in various domains such as healthcare, finance, and news articles. 8. Question answering. Langchain has been applied to build question answering systems that can respond to user queries in natural language. These systems are able to understand complex questions and provide accurate answers, making them an attractive solution for customer service and tutoring applications. 9. Text classification. Langchain has been used to develop text classification tools that can categorize text into predefined categories such as spam, non-spam emails, or positive, negative reviews. These tools are able to handle noisy and unstructured data, making them effective in real-world applications. 10. Event extraction. Langchain has been applied to develop event extraction systems that can identify events and their corresponding attributes in text. These systems have been used in various domains such as news articles, social media posts, and legal documents. In conclusion, Langchain is a versatile framework that has been successfully applied in various real-world use cases of natural language understanding, generation, and AI development. Its ability to handle complex language structures and idiomatic expressions makes it an attractive solution for businesses and organizations looking to automate their NLP tasks. As the demand for NLP applications continues to grow, Langchain is well positioned to meet these demands and provide innovative solutions for a wide range of industries. We would like to extend our sincere gratitude to the following individuals and organizations for their valuable contributions to the creation of Fundamentals of Machine Learning, a no-code, no-math book on understanding the fundamentals of modern milliliter and AI. 1. Introduction. We are grateful to our editor for providing us with a comprehensive overview of the book's contents and helping us craft an engaging introduction that sets the tone for the rest of the book. 2. Artificial intelligence. We thank open source community for their insights into the field of artificial intelligence and their assistance in writing the chapters on AI. Their expertise has enriched our understanding of this complex and fascinating topic. 3. Differences between classical programming and artificial intelligence. We appreciate the input of the open source community in highlighting the key differences between classical programming and AI, providing a solid foundation for our discussion on machine learning. 4. Machine learning. Our deepest appreciation goes to our DS, who has graciously shared their extensive knowledge of machine learning techniques and algorithms. Their guidance has greatly improved the quality of this section. 5. Deep learning. We are grateful to thank open source community for their contributions in crafting a comprehensive overview of deep learning, including its applications and challenges. Their expertise has enhanced our understanding of this critical aspect of modern milliliter and AI. 6. Applied vs. Generalized AI. Our sincere thanks go to multiple research papers for shedding light on the distinctions between applied and generalized AI, helping us provide a more nuanced perspective on the field. 7. Machine learning features and labels. We appreciate the input of multiple articles in clarifying the importance of features and labels in machine learning, ensuring that our readers have a clear grasp of these fundamental concepts. 8. Machine learning training models. Our gratitude goes to multiple research papers for their contribution in crafting an informative Chapter on Machine Learning Training Models, including the various types and their applications. 9. Machine Learning Supervised Learning. We thank interns for their assistance in writing about supervised learning, including the different approaches and techniques used in this subfield. 10. Machine Learning Classification. Our appreciation goes to inventors for providing insights into classification, one of the most important tasks in machine learning, and helping us write a comprehensive chapter on this topic. 11. Machine Learning Regression. We are grateful to DS for their contribution in crafting an informative chapter on regression, including the various techniques and applications of this subfield. 12. Machine Learning Unsupervised Learning. Our sincere thanks go to our DS for shedding light on unsupervised learning, including the different approaches and techniques used in this subfield. 13. Reinforcement Learning. We thank our DS for their assistance in writing about reinforcement learning, including the various approaches and applications of this subfield. 14. Generative AI. Our gratitude goes to our DS for providing insights into generative AI, including the different approaches and techniques used in this subfield. 15. Large Language Models, LLMs. We appreciate the input of our DS in crafting an informative chapter on LLMs, including their capabilities and limitations. 16. Openai. Our sincere thanks go to our DS for shedding light on Openai, a leading organization in the field of AI research and development. 17. Llama 2 Meta AI. We thank our DS for their contribution in writing about Llama 2 Meta AI, including its capabilities and potential applications. 18. Hugging Face AI Community. Our gratitude goes to our DS for providing insights into the Hugging Face AI community, including its contributions to the field of AI research and development. 19. Langchain Framework. We appreciate the input of our DS in crafting an informative chapter on the Langchain framework, including its capabilities and potential applications. In conclusion, we would like to express our heartfelt gratitude to all those who have contributed to the creation of Fundamentals of Machine Learning. Their expertise and insights have greatly enriched this book, and will undoubtedly benefit readers seeking to gain a deeper understanding of modern milliliter and AI. Glossary of Key Terms for Fundamentals of Machine Learning. Here is a list of key terms and definitions that are covered in the book, Fundamentals of Machine Learning. A/B testing, a method of comparing two or more versions of a product, service, or process to determine which one performs better. Artificial intelligence, AI, the broader field encompassing machine learning, including rule-based systems and expert systems. Classification, the task of predicting a categorical label based on input features. Deep learning, DL, a subfield of machine learning that uses neural networks with multiple layers to learn complex patterns in data. Differences between classical programming and artificial intelligence, an overview of A. Differences between traditional programming and AI, including the use of algorithms vs. rules and the focus on efficiency vs. generality. Features, descriptive statistics that capture relevant information about a dataset, such as mean, median, mode, standard deviation, etc. Generalized AI, the ability of an AI system to perform any intellectual task that can be performed by a human. Inductive learning, a type of machine learning where the model learns from a set of examples or instances and makes predictions based on those patterns. Labels, the target values or classes predicted by a machine learning model. Large language models, LLMs, AI models that are trained on vast amounts of text data to generate language outputs that are Coherent and natural sounding. Machine learning. Milliliter. A subset of artificial intelligence that involves training algorithms to learn from data and make predictions or decisions without being explicitly programmed. Neural networks, a type of machine learning model inspired by the structure and function of a human brain, composed of interconnected nodes or neurons. Reinforcement learning, RL, a type of machine learning where an agent learns to take actions in an environment to maximize a reward signal. Supervised learning, a subfield of machine learning where the model is trained on labeled data to make predictions on new, unseen data. Unsupervised learning, a subfield of machine learning where the model is trained on unlabeled data and makes discoveries or patterns without any prior knowledge. Validation set, a set of data used to evaluate the performance of a machine learning model during training, separate from the training data. Appendix, machine learning resources. In addition to the chapters included in this book, there are many resources available for further learning and exploration of machine learning in artificial intelligence. Here are some key resources to consider. Openai. Openai is a non-profit organization dedicated to advancing the field of artificial intelligence. Their website provides access to a wide range of research papers, tutorials, and resources on topics such as deep learning and reinforcement learning. https openai.com/large language models, LLMs. LLMs are a class of machine learning models that have been trained on large amounts of text data to generate language outputs that are coherent and natural sounding. Popular LLMs include BERT, Roberta, and XLNet. https llm.openai.com/. Hugging Face AI Community. The Hugging Face AI community is a vibrant online community of machine learning practitioners and researchers. The website provides access to a wide range of resources, including tutorials, research papers, and code repositories related to machine learning. https huggingface.co/. Reinforcement learning. Reinforcement learning is a subfield of machine learning that focuses on training agents to make decisions in complex, dynamic environments. The website provides access to a wide range of resources, including tutorials, research papers, and code repositories related to reinforcement learning. https reinforcementlearning.com/. Generative AI. Generative AI is a subfield of machine learning that focuses on generating new data samples that are similar to a given dataset. The website provides access to a wide range of resources, including tutorials, research papers, and code repositories related to generative AI. https generativai.com/. Openai Gym. Openai Gym is an open source platform for training and testing reinforcement learning algorithms. It provides a simple interface for defining tasks and training agents, as well as tools for evaluating and visualizing agent performance. https gym.openai.com/. TensorFlow. TensorFlow is a popular machine learning framework that provides tools for building and training machine learning models. It includes a wide range of pre-built estimators and algorithms, as well as support for custom model development. https www.tensorflow.org/. PTorch. PTorch is another popular machine learning framework that provides a dynamic computation graph and automatic differentiation. It also includes tools for building and training machine learning models. https pytorch.org/. Bibliography. Books. 1. Mitchell, T. M. and Beecham, J. C. 2013. Machine Learning. McGraw-Hill. Asterisk provides a comprehensive introduction to machine learning techniques and algorithms, including supervised and unsupervised learning, linear regression, neural networks, and more. 2. Bishop. C. M. 2006. Pattern Recognition and Machine Learning. Springer. Asterisk covers the basics of machine learning, including linear regression, classification, clustering, and neural networks, with a focus on practical applications in computer science and engineering. 3. Hasty. T. Tibshirani. R. and Friedman. J. 2009. The Elements of Statistical Learning, Data Mining, Inference, and Prediction. Springer. Asterisk offers a comprehensive introduction to statistical learning methods, including linear regression, classification, and time series analysis, with a focus on practical applications in data science. 4. Murphy. K. 2012. Machine Learning, a Prototypical Approach. O'Reilly Media. Asterisk provides an introduction to machine learning techniques using a prototypical approach, covering topics such as supervised and unsupervised learning, neural networks, and more. 5. Norwig. P. and Russell. S. J. 2010. Artificial Intelligence, a Modern Approach. Prentice Hall. Asterisk covers the basics of artificial intelligence, including machine learning, neural networks, natural language processing, computer vision, and more. 6. Tong. Y. and Hinton. G. A. 2018. Lecture Notes on Deep Learning. University of Toronto. Asterisk provides an introduction to deep learning techniques, including convolutional neural networks, recurrent neural networks, and more. 7. Goodfellow. I. Bengio. Y. and Kervill. A. 2016. Deep Learning. MIT Press. Asterisk offers a comprehensive introduction to deep learning methods, including supervised and unsupervised learning, neural networks, and more. 8. Liu. P. Lee. J. Liu. X. and Sun. R. 2017. Machine Learning for Computer Vision. CRC Press. Asterisk covers the basics of machine learning techniques as applied to computer vision, including object detection, image segmentation, and more. 9. Zhang. S. and Lee. X. 2018. Machine Learning in Health Informatics. Springer. Asterisk provides an introduction to machine learning methods as applied to health informatics, including disease diagnosis, patient outcome prediction, and more. 10. Joachims. T. 1997. Making Large-Scale SVM Training Practical. Proceedings of the 14th International Conference on Machine Learning. ICML. 97. Asterisk discusses techniques for scaling up support vector machines, SVMs, for large datasets, including parallel computing and kernel methods. Journals. 1. Neural Computing and Applications. Asterisk provides a platform for publishing research on neural networks and related topics in machine learning. 2. Journal of Machine Learning Research. Asterisk offers a forum for publishing original research in machine learning, including papers on supervised and unsupervised learning, deep learning, and more. 3. IEEE Transactions on Neural Networks and Learning Systems. Asterisk publishes articles on the latest advances in neural networks and related machine learning techniques. 4. Machine Learning. Asterisk covers a wide range of topics in machine learning, including supervised and unsupervised learning, neural networks, and more. 5. Journal of Artificial Intelligence Research. Asterisk provides a platform for publishing research on artificial intelligence, including machine learning, natural language processing, computer vision, and more. 6. Knowledge-based systems. Asterisk covers the latest advances in knowledge-based systems, including expert systems, intelligent agents, and hybrid approaches to AI. 7. Journal of Intelligent Information Systems. Asterisk provides a forum for publishing research on intelligent information systems, including machine learning, data mining, and knowledge management. 8. Computational intelligence. Asterisk covers the latest advances in computational intelligence, including machine learning, neural networks, and hybrid approaches to AI. 9. International Journal of Machine Learning in Cybernetics. Asterisk publishes articles on the latest advances in machine learning in cybernetics, including supervised and unsupervised learning, neural networks, and more. 10. Neural computing and applications reviews. Asterisk provides a platform for publishing reviews of recent advances in neural computing and related topics in machine learning.